My name is Michael Bell. I was just going to take one moment to reintroduce the panels. There are 2 panels left this afternoon, followed by an evening keynote lecture by Michael Graves that will be in a separate auditorium, and Ben Prosky will help guide us there later today. And then obviously we reconvene tomorrow morning with 4 panel discussions, followed by an evening end-of-the-day wrap-up roundtable discussion led by Mark Wigley. In introducing this next body of work, I will hand this over to Galia Solomonoff, a member of our faculty and an architect in New York City, has been a speaker at the conference before. In putting together this conference, as I mentioned this morning, this is really a curated event, meaning that people were invited, chosen, and paired. Some of these groupings might seem rather obvious. Some of them you might have to listen and read between the lines before it becomes clear. But this next panel, which is titled Architecture, Plastic Life, Life of Plastics, suitably cryptic title, unfortunately, but it is a group of people that as we were organizing the conference, we began to realize that perhaps for a generation of architects who have been incredibly inventive in setting up not only their work, but their practices, that this would be a group of people who we believe have an altogether different relationship to some of the architectural and technical histories around polymers that were presented in the morning session. And as that dawned on us, we realized that, in fact, trying to make polymers a preeminent or central question to some of these people's work would, in fact, not be necessarily the case or appropriate, that they might, in fact, see polymers in a more distributed way or equivocal to other materials. So I will leave it to Galia to make a different introduction or something more succinct, because she's been discussing it with them on a daily basis. And the degree to which all of this makes sense, we'll see. But the work itself will obviously be really exciting. Thank you very much.
So I have a very sophisticated time controlling device. So my name is Galia Solomonoff. Thank you, Michael Bell, for doing this, for putting all this panel together. Columbia, GSAPP, and my co-panelists today, Anna Dyson, Winka Dubbeldam, Sheila Kennedy, and William Pearson. Thank you, everyone, for being here today. I want to start with Michael's question. In the mid-1950s, the promise of plastic took on an utopian guise and also an image of total design. Is it possible that plastic propel an era of engineered design in which in turn betray the flexibilities that plastic offer at a chemical level? And my answer is yes. It actually depends. If we're talking about plastics in the context of art, architecture, engineer, product design, or urbanism. Today I will talk about art and architecture because I feel they relate to the issue of plastic promise, total design, and betray sensibility, and also because I've been looking for an occasion to talk about this because it's part of my immersive interest right now. And so when we talk about art and life, we go to Warhol in some extent. So I want to be plastic. And so plastic is this, it's an immersive material. It's everywhere that we turn. Architecture is also everywhere, but at the same time, both architecture and plastic have the task of remaining unobtrusive, unnoticed. So at once they're everywhere, and at this other end, they're supposed to not call too much attention to itself. At least that's the way, one of the ways in which I see architecture. Yet, plastics and architecture have reshaped, retextured everything we know and touch. Yet the way in which we talk about plastics, it's not comparable in breadth or frequency to, say, glass or concrete. This is a sketch I did yesterday night while looking at Greg's presentation. And so artist, architect, engineer, we all have ideas. The ideas go from risk to no risk, and we go from safety to ridicule. And we, these ideas either get built or not, they get shown or not, they get praised or not, they get ignored or not. And the people at the other end, in my practice, are critics, curators, and collectors, and users of sorts. But those are the people that qualify what I'm interested in doing or defining. So the area that I'm going to talk about today is the area at the risk end that is also the ridicule end. And that's an area that I would be very proud to be, at least for a partial brief moment. I don't want to be ridiculed forever, but I don't mind being ridiculed for a little while. And so today I'm going to see you a couple of projects. So I'll show you a couple of projects. So sometimes we simply take risks. There's no real explanation to why we do certain things, but we do them, and we grow with them. And so if I really wanted to explain you how these work, I would need to go into Freud and this image, which I cannot do today. If you need to do such a thing, I have sessions. I give sessions. So the area that, this area where risk and ridicule is, if I can give you a moment in an architect's career that this has happened, I think about 3 images. One is Frank Gehry cardboard moment. So you see a kind of decrepit interior of a house. It's kind of decrepit. It's not totally decrepit. With sheetrock, kind of half plaster, and you see a cardboard chair, and that's a moment that is at the tip of being ridiculous, but at the same time incredibly moving. When I think about Diller Scofidio, I think about the slow house. When I think about Greg Lynn, I think about the dolphins in the plastic fountain. And when I think about, and so that's a very interesting moment. And then years later, when you say, how come Diller Scofidio can do such amazing buildings at, Alice Tully Hall and all these things that they are doing, all you need to do is to refer to that brave moment in which they confronted something that was beyond their comfort zone. And so that is what I see artists doing frequently and architects doing infrequently but significantly. And so this is me on the safe mode. This is me doing DIA, and this is interesting, but the people that are really enjoying themselves and having fun and taking risks are the artists. I'm there as the supportive therapist, mother, some kind of other function that the architect also performs, and a function that I like and I embrace. And so this is Michael Heiser installation at DIA. It's a precipice of 20 feet, and he wanted to do this without a railing. And we tried to convince the building department of the city of Beacon to do it without a railing. Luckily, the building department was our alter ego and said, no, you cannot do that, you have to have a railing. And that's a good thing, because the day of the opening, my mom walked to the edge and thought that was painting. It was a painting on the cement and almost stepped in. So that's about risk and safety. And so Andy Warhol again, and the Velvet Underground, and the exploding plastic inevitable show. Exploding plastic inevitable show. So this show was 1966, Sarmar Place. He rented for $150 for 1 month a place that was a Polish community center. A one room, I think it was about 30 feet by 25 feet. So now it's a mystical show. It's a show that is in every book about pop art. Was actually almost a pathetic event. Imagine a room in a community center on Salmark Place in 1966, and it has inflatable pillows on the ceiling, and so I want you to see this moment where you do something that is almost silly, but at the same time, it's your guts that are out there. And Warhol did it, and he invited all his friends. And his friends were Lou Reed and Nico, the Velvet Underground. So it was a room, and then he put these pillows, and then he projected this light, and it was the plastic inevitable. What is it? The name again? Exploding plastic inevitable. So this is another image that fascinates me, and I think reveals something of what the things that we're talking today. On the one, you have 4 buildings here, 4 attitudes towards architecture. You have the Eiffel Tower that stands for heroism, tectonics, all those things. You have Notre Dame. Notre Dame is spirituality, communion, everyone working together in stone forever, eternity. You have modernism, function. Don't do anything that you cannot use. Just get rid of everything, except if it's useful. And then you have a red balloon, and that talks about plastics, and it talks about, I think to me, spirituality, getting things, kind of like a sense of emotions. And so, and that too, you have, here the two are working together. On the one hand, you have the heavy and the light, the structure and the loose, the one that communicates easily, the one that communicates in a more cryptic way, working together. So it comes down to I'm heavy, I'm light, and in this project, it's a nursery for in Brooklyn that we're doing. There's an inflatable office, and there's a bathroom. And then there's this image. This is a Decoy Tank. You can buy these for $250. How much is Fabian? Like $500, $250? Something like that. Okay, so this is an inflatable tank. And this is a ridiculous idea, but actually works. This is used by the military to pretend that they have an army that they don't. So they do everything. They do the tanks, the airplanes, and you can mount an entire area, and this will allow you to make calculations of how much armament there is, but it's really an inflatable plastic thing. And this is also an idea that goes to the other end. This is a stainless steel balloon dog by Chef Kool's. The light and the heavy. And another thing that ties plastic to an important part of our lives is plumbing. Plastic carries water in an amazingly efficient way. And so whether it's for fun, like in here, or whether it is for piping and water tanks that we'll see later, it does this very well. Another thing that was touched upon yesterday was the idea of the brick as having a textile quality that allow us to lose sight of the fact that a building is made out of parts. If you put enough small bricks together, the bricks disappear. Like the weaves disappear in a scarf. They just merge into the total form. And so this is a project, the effective brick. This is my ridiculous moment. So I try to do take the brick to the limit of what it can be. And this was a show in Artist Space, curated by an artist curator. And so I tried to do a wall. First I started digitally, and it looks kind of more dignified when you look at digital pictures, at digital images. But then when you go to the actual painting, and to the actual mold making, we did 30 molds, and we casted 650 bricks, hydrocal bricks for this. All my students, some friends did this. Some molds are made of rubber and silicone. This is us working in Brooklyn. These are the bricks. You can tell that I can't explain that. I can't explain why I like that form. And this is the installation. The installation was done at night when everyone would go in the gallery at about 6 p.m. I would work until 6 a.m. for 4 days and install these. And the materials that I used for the installation, oh my God, were silicone as the mortar, aluminum tubing as the reinforcement, and so it was, and then I did these plastic bricks that are vacuum form styrene bricks, and that was it, and I'm ready to do another version of that now. So if anyone is interested to take that experiment further, I'm too. So that is the installation as it was done with 600 bricks at Artist Space. And then the other last thing that I'm going to show you very quickly two things. One is water tanks in Rio. Last year we did a show, we had a studio that was Rio de Janeiro, the Olympics, and one of the students, Nick Hobson and Clara Robston, did this project, and it consisted of 600 balloons that it could reconfigure in different ways. For example, it says Rio 2006, and the balloons had a water tank and internet functions within it, and a big balloon that would collect, it had a gutter all the way around, so it could collect all the water. Then the water could be nested in the tank. The tank water could be filtered, so it could become drinking water, and there was an antenna connected to this, and the antenna provided internet service for the neighborhoods. And so for the beginning of the Olympics, they were all going to be grouped. Everyone could log in. All the visitors to the Olympics could use the 600 capsules as a telephone unit, kind of, or computer unit, and then they would travel to the different neighborhoods that needed water supply and internet. And so this is the balloon kind of cycle of rising up, using air to transport, and being directed to a new location. And this is the balloon in the pier, and that's a balloon in the neighborhood. This is the closing ceremony of the Olympics, where all the balloons will be let go together. And so this is where I go back to Warhol and the idea of an amazing party. And not an amazing party as a waste, but an amazing party because we deserve an amazing party. Parties is what we've done since we were primitive people. It's what brings us together, it's what communicates. And so I imagine the event, the party, as being as important to the people of Rio as it is to me or to anyone here, and as a serious thing that an architect could get behind and design. And so this is the closing ceremony, all the balloons going to the neighborhoods. The pier now transitions into a market with some open air kind of solariums, and the market is underneath. The balloons go to the neighborhood. This is the neighborhoods that we were looking at. And this is the post-Olympic landscape of Rio de Janeiro with the balloons in the different neighborhoods and the pier being a pier. And then the last project that I'm going to show you, it's a pavilion that we're doing this summer. And so we look at the history of pavilions, pavilion being an essay of architecture, kind of like it combines the ability to do something radical and extreme with the difficulties of building something. So I don't want things to remain digital. I have nothing against digital anything. It's like, what I feel is like it's much more easy to look silly and ridiculous and exposed when you're dealing with materials and you made a miscalculation that it is to do that when you're dealing in the digital realm. So we choose 3 pavilions that we really liked. We analyzed them. We analyzed all of them. And then I'm working with Liam Gillick, an artist. So the question is, why do I bother working with an artist? Well, I'm interested in learning how to do things. Don't necessarily want to follow the way things are done anywhere. And that leads to an unsafe territory of experimentation that is often more at home in the artist's realm. 2 significant differences are apparent now that I'm working with an artist. One is the fact that we as architects, we always work with other people's money. And that is something that we're very trained to internalize. And the other thing is that we have an intricate relationship to function. We are, and so we're in working with artists, a lot of our thinking has been shaken. So we meet once a week, 3 times a week with architecture students by ourselves, and 1 time a week with art and architecture students. And we sit together and we talk about different things. And the discussions, I wish we could do a building that represented the discussions. It's, the building is going to be partial, the discussions. And so our site, it's behind Avery, between Avery and Fairweather. And it's this inflatable cloud and a bathroom, a public bathroom. Because one of the things that we realized is that a society that cannot provide public bathrooms, that does not deserve public art. And so that's one of the things that we came up with in the class, and it's based on Carl Andre. And so we're providing a public bathroom and a cloud. And that's a public bathroom, that's a cloud, and that's the end. Thank you.
Galia will take over after this while she's de-microphoned, but this is Anna Dyson, Director of CASE at RPI. Thank you.
Just see if I can. Okay. Well, thank you. It's an honor to be here with fellow panelists and to be back. We've had a really interesting discussion, and one of the questions that Galia asked us was, are we essentially pessimistic or optimistic regarding plastics? And I couldn't answer it, especially given this global introspection that we have right now regarding the irrational exuberance that might have been surrounding the design of the Fukushima plant and other sort of attitudes towards technology that is part of our near-term legacy. Because certainly, we are aware of the consequences. We have massive seas of plastic floating on our oceans. But I would say that now that I believe one should be forced to answer that question, actually, because I think it's one of the most important questions. And so I thank you for starting with that, which is that what is our essential stance, our essential philosophical and existential stance towards something? And I would say I'm essentially optimistic. And the reason being that I think that we're living in an amazing moment. We're living in this incredible moment of crisis where our relationship to the natural environment is being forced upon us. We're being forced to really recognize how we have, in a sense, extended ourselves out into the environment. And this whole issue of thinking that we can control procedures, so-called natural procedures, is something that is patently obvious that we cannot do. And that we somehow have to think about flows and natural flows, even in the most apparently controlled environments. That relationship between the built and the living will have to be reassessed at multiple scales. And so I look at plastics, and I'm going to sort of present this for those of you that were at the Metals Conference. It's a bit of a companion piece to what I presented at the Metals Conference last year, which is that I was really looking at how we manipulate a material at multiple scales, and especially how we are now at a moment where we can use computation to literally design the morphology of materials at multiple scales and potentially simultaneously, and start to look at those interdependent relationships across scale. But I think what is amazing about polymers and the polymer family in relationship to that is that we're also at a simultaneous moment where we've extended ourselves so far in the engineering of materials that it's meeting something where the kind of our understanding of geometry of biotic processes is also converging with our understanding of the manipulation of materials such that it might be so-called biocompatible material. I'm just going to use a dumb analogy because it's one of the materials that I'll introduce that we're working with right now are hydrogels that are really very close relatives to contact lenses, or what you have in your eye. And for those of you that are old enough to remember placing a glass contact lens into your eye, that might be 20, 30 years ago, remember how uncomfortable it was to put ceramic into one's eye. But somehow a polymer is almost imperceptible. It's an amazing thing where there's this kind of blending of processes with a phenomenal level of engineering at a kind of extremely small scale. So we're looking at, all the way down to this kind of manipulation of scale at the nanoscopic level. But in order to kind of, in a sense, try and be critical, and we're certainly a case where we have been accused of being technophiliac, and we often are. We get very exuberant about possibilities and horizons. But I would say that one of the things that I think has to be discussed in relationship to plastics is this relationship to energy, the metabolization of energy in materials, because it goes both ways, as we'll see, I'm sure, in the presentation of my colleagues doing phenomenal work, both in plastics, but very critical of plastics as well, as I think we all have to be. In reality, this is a bit of a chart that's going to show you what I'm going to present today, and I'm just going to use some examples of our own work. So just looking at the range, I'm going to actually end at this top level, which is looking at very, very low-tech processes for taking post-agricultural waste byproducts that are essentially polymers, in this case coconut coir, pressing them at very low heat and developing mechanical properties with those materials for both desiccation and also structural characteristics that rival some of our most high-tech materials. And these are processes that were known to tropical areas of the globe in India and other areas 2,000 years ago. So it really puts into question a lot of our high-tech processes. But I will begin with some of the high-tech processes because they're exciting and they do offer another aspect, another way to potentially look at polymers in relationship to biotic processes. And I just, I'm going to repeat something that I did last year, which is just consider the notion that any change that we make in geometry at the atmospheric level is resonated and interdependent with changes in the human body at the DNA scale. So I think this emergence of consciousness is something that is quite phenomenal, and this is something that we really take into account in our work, that we have the opportunity to engineer these systems at a very, very, and the morphology at a very, very small scale. But as we actually start to manipulate morphologies at a small scale in order to be functional, so-called, have functions or reactive characteristics that we might think are more, in a sense, environmentally responsive, potentially more effective in terms of what we're trying to do, the embodied energy dramatically increases, so that we've actually developed processes to manipulate materials, but they are possibly driven through unsustainable means. So we're at this kind of conundrum. And just to start that discussion, one of the first projects that I'll show is in relationship to this issue of control. I think, if we're going to look at the relationship between biotics and plastics in another sense, we also really do need to look at our legacy in terms of an architectural culture, which over time has really been about pretending that we can remove biotic processes from the process, and that we're trying to, in a sense, control the reactive characteristics of architecture and the dynamic characteristics ultimately. So this is a project where we were, where we are, and sort of in development, very interested in looking at interdependent relationships of this morphology at multiple scales. We're looking at dynamic flows of air through root rhizospheres. And as a lot of our research does come from aerospace, this, interestingly enough, comes from studies in closed-loop ecologies for space stations, literally over the last four decades, looking at how we might actually look at the introduction of oxygen and the remediation of toxins in our environment through biotic processes, plants, essentially. And that geometric relationship of moving air through the root rhizosphere and through bacteria led the researchers to discover at NASA in the 60s that you could actually remediate toxins in the air, common toxins such as VOCs, a lot of stuff that's actually sort of coming into our environment right now that we remediate through mechanical means, and practically all of these surfaces are plastic that we're looking at, including the paints and the furnitures, et cetera, that are basically off-gassing VOCs. So the issue is that plastics are not inert. We know that. They affect our biology, and then we actually have to respond to that. But the question is, can we respond to it in a way that is holistic? So the engineers were looking at these kind of interior space capsules that are all plastic environments. And it introduced this incredible condition where they could easily introduce oxygen, but they could not remediate the VOCs coming off of the plastics. And that relationship between certain types of bacteria in the root rhizosphere that would actually metabolize these conditions as food became something that was an incredible discovery to them, whereby they could amplify the air cleaning capacity of plants by 200 times by blowing air through the rhizosphere, as I'll show in a minute. But more important, what I wanted to talk about is this issue of fluid dynamics and plastics in relationship to airflow, in relationship to the spatialization of these conditions, both with new and existing construction, how we might intersect with those geometries at multiple levels. So we literally look at the root rhizosphere. If you think about just looking at this space, and I think it's always amazing to just kind of consider where we are, how air is being introduced into this space, how we take it out, the kind of dynamics of breathing and business machines and everything that are coming into this. It's an unbelievably complex environment that we've created for ourselves, and one that very little intelligence goes into that complexity in terms of its design. We over-design everything, and we really don't really understand those processes in terms of what we would call so-called built ecologies. And so these studies are really looking at that relationship, the relationship between the fluid dynamics of air, how it moves through, let's say, a room or a building or even a district, and then all the way down to that small scale, as we talked about at that first slide, the kind of micro scale of the root rhizosphere. And what happens when you go all the way down? It just so happens that those images that I just showed happen to be plastic modules, and we're definitely, looking at all of these existential questions relative to plastics, such as design for disassembly, reassembly, design for recycling, biopolymers, biodegradability. I mean, there's sort of epic questions right now with respect to what we are doing with plastics and how they participate in future ecologies. But geometrically, what's fascinating is another sort of NASA discovery about the relationship between minimal surfaces and flow really do also emanate from biology. So I want to kind of constantly reinforce that so much of these discoveries and our relationship between polymers, there is a crossover right now that is really coming to a head. I would say in this case in our work in a very particular way, whereby we have these kinds of, I love Galia's sort of characterization of a kind of goofy, ugly phase that things go through, because to be honest, we constantly talk about our stuff as a kind of high wire act without a net. And this is one of them. I mean, this work is really ultimately proposing that you could produce fresh air from within buildings. Would they be tight? Maybe. If you live in Bangkok, maybe you want a tight building. Santiago de Chile, other places where there's very compromised exterior air quality, you can produce fresh air or lungs from within a building. I mean, we're not interested in these kinds of questions about extreme, interior, exterior, whatever it is. It's mostly a kind of omnidirectional study. What are the relationships that we're setting up between interior, exterior, et cetera? And we're sort of, looking at those and reconsidering them from a kind of basic sense. So ultimately, we look at what we're doing with plastic environments, and ultimately there is a relationship, and a kind of tight relationship, with the metabolism of biotic systems. And so just moving, I think we've got to move very quickly through this, but just looking at how we study those, how we investigate those. In our case, you know, in terms of that relationship between the sort of manufacturing level, the biotic level, we're constantly looking at how much built material do we need, how much natural material do we need, and what is that relationship between it. So it's this kind of ugly, sort of awkward smashing together or merging together of biotics, mechanics, polymers, into something that is a kind of performative prototype that can perform the best we know how with existing or emerging technologies, but is something that is certainly at, I would say, that highly experimental phase that Galia was referring to. I don't know if we can come up to the ankle of the Slow House by Deleuze and Scafidio, but really we are in this kind of very, very investigative period looking at that relationship between flow. So if you look at a square room, the question is, how does the airflow go through a square room? It's in a very, very different form than what you actually see in front of your eyes. So what is that relationship between form and performance in terms of the dynamics? And so just placing, this is an example of a prototype here in our, in the lobby of Skidmore, Owings & Merrill, one of our partners, actually our principal partner at CASE, and we moved this prototype in different capacities in different rooms, testing the remediation of toxins and the relationship between species and performance. Ramping up in scale and looking at these kinds of large-scale constructions, a proposal that then gets incredibly rationalized in this case also, so that the kind of optimal geometric plastic relationship to dynamic flow is not necessarily always viable in the real world, of certain constraints within constructions and very sort of orthogonal architectures that we're placed into. This is a kind of retrofit into an existing design for an emergency call center where the lungs of the building are basically within. You know, if it has to be completely shut off from exterior intake, it produces fresh air for potentially posterity from within the building. It's, you know, looking at a very large-scale biotic and biological experiment. One of the aspects about dynamics also and control that brings to mind, I mean, are we really comfortable with bringing in natural processes and natural systems into our environment wholesale? There are huge cultural ramifications. Going down in scale a little bit into the filming of polymers onto substrates and onto materials is a very interesting possibility to have reactive conditions whereby the exchange of information is possible. In this case, this is an area of inquiry that we have that is looking at the adhesion of electroactive polymer to basically IGU units or window displays, where literally, if you think about ceramic frit that's once again fixed and non-reactive, we're looking at something that is like a movable frit that can be any pattern depending on what you program for it, or that it can be opaque, it can be translucent, and everything in between. Transparent actually is its default condition. It also can be scalable. You know, you can start to sculpt space or change the shape of space. You can change the effective heat transfer characteristics of a building envelope very quickly within a switch, in terms of the way that it absorbs solar heat gain and the way that it responds to glare, et cetera, with geometric properties, once again, that are built into the microscale of the material. I've just been given minutes, so I'm gonna flip through very quickly, because I think it's better to have a kind of overview of the discussion. I mentioned contact lenses. This is literally a ceiling made out of contact lenses. It's an intelligent hydrogel that is geared towards hot, humid climates. In this case, there was a test bed for a projective building for the Mumbai airport. And so what we're really doing, in a sense, at CASE is kind of projecting into the future with existing technologies, and looking at the time period of, let's say, a Mumbai airport, and looking at, I think Galia's comment about water is such a great one, because we think about the relationship between polymers and water like this. In this case, this is looking at a hydrogel, a material that absorbs water and captures it for potable water purposes and redistribute it. Also, you know, at the ceiling level, also potentially also dramatically changing the kind of psychrometric profile of the city. I mean, a city like Mumbai, unfortunately, has tremendous amount of humidity in the air, but very serious water shortage problems. And I think that if I were to just, I probably have no time right now, so I'm just going to flip through these slides really quickly. And just end on this note, which is looking at the post-agricultural waste byproduct. And I want us to think about polymers in a very, very large sense. There are the manufactured polymers that we have that have tremendous limitations and in certain cases nefarious effects, serious nefarious effects on the environment. But we also have a very, very large range of polymers that are also participating in the in many of the different processes that we have. And if we have, a chance to actually look at the relationship between food production, natural processes that we are using, and how we are actually using them, we actually have enormous surpluses of so-called polymers that can participate in biopolymeric processes for building materials, for the gestation of different metabolistic processes that we have within buildings, whether it be energy, water, toxin remediation, et cetera. And this is, a very, very low-tech process. As you said, this is literally the kind of heating at a fairly low temperature of coconut core, which is, and coconut husk, which the dramatic majority of these materials are wasted throughout the hot, humid belts that probably need them the most, because they're actually building with very, very heavy thermal mass concrete buildings, predominantly now in these belts around the world, dramatically changing their microclimates and their requirements for cooling, et cetera. So, these materials have incredible properties, and they actually behave in such ways that can really look at that metabolization and look at the kind of relationship between what we have as natural resources and how we metabolize those natural resources within the built ecological environment that we're putting out. So I just put that as a kind of open-ended question, because I know that I've got somebody here that really would like me to move on. So thank you very much for your attention.
Sheila Kennedy, Professor of Practice, MIT School of Architecture and Planning.
You'll notice our Director of Special Events has two signs. One says 5 minutes, the other says 2 minutes. And he's quite efficient at letting you see them. So for those of you that are speaking, please don't be offended. It's got to do with preserving the overall and to the benefit of all. But thank you very much.
Function 5. So I'll use this moment, since I am the anti-intellectual here, or the grim reaper of speakers, to say that there are some unsung heroes in this, and that is our students, who are working beside me, behind me, back there in the booth, out there, and they keep these conferences really running. They get involved months before, and I am truly grateful. That's why it's great to do this in the school. So give them a round.
And then you want to run this one? Okay. You want to run this one first? All right.
Thank you. Thanks. It's a great pleasure to be here, and excited about the discussion. So I'm going to try to keep things moving. That was a great presentation by Anna Dyson. And what I want to do is actually a little bit risky, because I want to throw out some comments for discussion about the very uneasy relationship between plastic as a kind of material and the sliding scale of plastic as a concept about material. And on top of that kind of continuum, throw in a discussion about an emergent capability of plastic, which is actually to produce energy, to become alive, to transform light into electrical energy. So this is the kind of a paradigmatic first image, because of course plastic has always been implicated in the energy discussion. If we think about the petroleum materials, plastic is made of fossilized fuels, and it's certainly participated in all the kinds of economies of production and transportation of gasoline around the world, and also water. So it's this ability to kind of make something extremely thin, extremely strong, that has instrumentalized the kind of transport and capitalization of these two sort of most precious liquids in oil and also in water, in petroleum and in water. So what I want to do is kind of set this up by thinking a little bit about the notion of integrity. And in plastic, in this Bakelite advertisement, plastic is touted for its ability of all materials to have a kind of integral color. This is what fascinated, of course, Judd so much, and it was one of the kind of key attributes of plastic, the fact that it could be translucent, the fact that it could contain its own color, no need to apply paint, and this could be instrumental in kind of producing the continuous surfaces of minimalism and also of modern architecture. And so to that kind of integration or integralness comes this other capability to actually to transform light and to turn that into electrical energy. So the question is, does this accruing of capacities for plastic as this kind of material that we find that it's replaceable and it's a waste material on the one hand, yet it's also permanent, and that it adds up, it accrues, it never really goes away. We think about the gyres in the Atlantic and Pacific Ocean, and it can always come back in the form of recycled materials or upcycled materials. So plastic never really dies because it escapes those kinds of qualities that define living materials, including the ability to sort of be eaten by parasites and also to die. And plastics, for that reason, is free from the kind of cultural baggage, the cultural ethics of so-called natural materials. So I guess the question for me is, can the emergent paradigm of plastic power help to open up alternative material manifestations? And if it can, what are the possibilities and limitations, and what kind of spatial experiences might these engender, and what kind of social agendas might plastic power create? And so in doing this, I'm going to really super briefly trace out a kind of more mainstream lineage where plastic architecture becomes very thin, the membrane collapses, we have a kind of universalization of appliance, proto-infrastructure in the case of the cushicle, and a very, very thin skin. This is the kind of disappearing act, this is the kind of dissolving of plastic architecture in the face of media. And when I say media, I'm referring to electrical media. You remember that the cushicle was plugged into the car. Oh, gosh, okay. Thank you. All right, this is what now here we are. Okay. So the cushicle was plugged into the car, and the car provided its source of power. Today, we actually, if we had a cushicle, we could actually create a source of power in that. Enter then the kind of paradigm of the bubble, which has made its appearance already, I think, in this conference, and also in this panel. So this is, again, a case where the envelope is one continuous surface, and there's this conflation of building skin and cladding and media screen. So from the cushicle, we have more normative possibilities which exist today. This is the work of Professor Jan Kremers in his company Hightex in Germany, where we have the kind of taking of power plastics, plastic electronics, photovoltaics, and kind of integrating them into a more normative skylight condition, another kind of bubble. And this is a Cool Earth solar collector. This is an inflatable solar collector that drastically and radically kind of reduces the material expenditure that would normally go into producing solar panels and solar concentrators and solar collectors by actually just using an inflatable and reflective surface. So this produces a kind of a very lightweight new plastic infrastructure that has the ability to kind of be inflated and deflated, and I think has some implications for manufacturing. This is McMurdo Station in the launch of an atmospheric weather balloon, and anything that can be inflated, anything that's plastic, that's moldable and has form, can be collapsed, and this particular bubble failed very famously and collapsed. And it's that transition from a kind of a 3D form to a flat 2D form that I think is both the points to the new manufacturing paradigm around plastics and also to a kind of a social possibility. So I'm only going to show two, in the interest of time, I'm only going to show two projects. The first is a nonprofit project that we launched 5 years ago. It's called the Portable Light Project. You have the URL on your screen here, www.portablelight.org. And we're working all around the world, and this is really based on this very, very simple idea that you can have a textile that will be able to be completely flat on the one hand and be formed up into its final three-dimensional shape. So we work on this three-dimensional shape, and then we flatten it out, we squash it out, and it produces a kind of a portable infrastructure. And what happens then is that you're seeing here the matrix, which is a PET recycled plastic, the plastic photovoltaic, small kit here, which produces a USB out, an LED light, and all of the kind of peripherals that get plugged into USB today. So we have a kind of a very simple 5-volt platform that's being used increasingly for medical applications and so forth. And something like this has the ability to take individual people, to give them, let's say, a common set of adaptable soft tools and connect them with a network, in this case a cell phone network, to create a new kind of a political constituency. This is a project in South Africa. Here we're taking advantage of an existing mainstream infrastructure of cell phone telephony. In South Africa, you can receive a cell phone message for free. So that means that there are millions of characters, individual letters, that are in the air that this project amortizes. We did this project with Massachusetts General Hospital, and Zinita Bethela, who you can see here from iTeach in South Africa, and it was her idea to adapt the plastic photovoltaic into a hospital blanket, which itself contains a high degree of polymer non-woven, so that people who have HIV and multi-drug resistant tuberculosis can be outside, can stay warm, and so the sun's rays can help to cure the bacteria that causes TB. This is another instance of a project that's being done by Paso Pacifico, can you get that back up for me? Thank you. Paso Pacifico and the Clinton Global Initiative, where we are working with a group of local campesinos and campesinas in Nicaragua, and they have adapted the plastic electronics to patrol beaches. They get funded by World Wildlife Foundation. They formerly were poachers and now actually have the possibility to earn money by using cell phones, taking pictures of wildlife and uplinking that on the net, and at night that light is used to promote education. And this is just one last example of it, the kind of increasing thing that we're seeing now with citizen journalism. My friend Eric Herzmann at Ushahidi has developed a system that's being used in Japan now. This is an example of the mapping in Haiti. And so in Nairobi, Eric developed these flat bags using the portable light system and had them designed and tested by tailors. And I'll show you my colleague Charles Garcia just kind of playing around with this. He has a messenger bag here, and he's going to rip the flap off, and he will then show you how flexible that new infrastructure is. It's pretty indestructible, and when he's done playing around with it, he will put it on the stool. But while he's doing that, I think this points to a very new packaging for electrical infrastructure, right? This is a completely different way that could emerge from the third world to inform our first world here at home. Okay, so that's the flat project. We'll move along. So can we think about taking aspects of infrastructure and having architects focus on the architecture and the envelope in a new way? This is a project by a group in Argentina. We see soft plastics, soft lighting. How can we begin to think about that here at home? Very, very quickly, and to be a little bit funny, because we're talking about plastics today, I want to make the case against glass. In the case against glass, we have to think about what an ingot of silicon means in terms of embodied energy. You have to really heat it. You have to bring it to a very high level. It's extremely energy intensive, and any solar panel would, of course, be made in this process. And of course, not only is it made with a lot of energy, it's produced in buildings like this, clean rooms and so forth, that need to be supported by a lot of ducting, so the operational costs are very, very high to run, a lot of electricity and so forth. So this raises a question, which is, can we replace this material? And when we replace this polysilicon or even this monocrystalline silicon solar cell with a new material, what are the possibilities? What can we do when we literally unroll that ingot of silicon into something that's very thin and flexible? And so there are a number of characteristics that emerge in this material paradigm of plastic power. It's cheap, it's roll-to-roll processed, it's relatively inefficient. Yes, that's right, it's not efficient. It's a kind of an ambient surface harvesting, and it's ubiquitous, it's everywhere. It lends itself to flat-to-form flat production. It can be pop-up formed, it can be inflatable, and it's very, very highly adaptable with computation, how form can be controlled, and how we can then develop those surfaces into a set of 2D patterns. So you think about a set of networked hybrid furniture spatial architecture-like surfaces with integral infrastructure energy harvesting capabilities. And so getting back to those lineages, what then is the potentiality in architecture? Must it always become transparent and disappear? Must it turn into a bubble? Enter Lily Reich. Very, very briefly, there's, in our work, we're trying to recover another kind of minoritarian lineage of modernism, which is the soft partitioning system that Lily Reich developed in her Silk and Velvet Cafe project of 1927, and also, which was an incredible project. Matilda McQuaid, who's here today, has done an exhibit on this that was very influential, that really recovered Lily Reich as the kind of architect of this interior world, which had silk, it had white velvet, pale gold, highly, highly material. So this is the kind of moment that we're interested in, this particular junction right here of the Tugendhat house, where the curtain, which would have normally gone along the wall, begins to depart, right, and begins to come across and begins to become complicit and somehow equatable with the architectural partitioning schema in this project. And so that leads us to the last project I'd like to show, which is the Soft House project, where we attempted to take a very familiar material, a textile curtain, and ask it to do two other jobs: to harvest energy and to produce light, and also to use the curtain track as a distributor of DC energy, so that it could power all of these things relatively effectively without having all the power supplies and paraphernalia that we see here, because this house is AC, of course, it's alternating current, and it's just not that effective to power alternating current appliances like everything in your house with DC-powered solar panels. So very briefly, you may be familiar with this project, but it's conventional. There's a track system east, south, and west. We also developed a vertical curtain, which you can see here, in a way of densifying the photovoltaic material. We made a lot of different material prototypes, and we have a chance to test out this project and realize it with the International Baustellung in Hamburg in a set of prototype row houses that will be built in 2013. And I should say that, Jan Nippers, his firm Nippers Helweg, and also Bureau Happold are working together on this project, as well as Jan Kramers. So this is a row housing design and an operating system for this very low light level situation in Hamburg. And we have textiles that are creating a twisting responsive facade. And the underside of those textiles are reflective, so that they reflect light into the house. You can see the cross section here, very, very simple. A soft duct that's like a sort of a soft chandelier that moves up and down. The sets of interior curtains that distribute light and energy, and then the exterior textile, all of which are polymer materials, PET recycled on the inside and PTFE on the outside. And just a view of what that looks like, the different surfaces of the deck, the nature inside, and the kind of soft duct that's controlling that. And I'll just conclude by showing you just a little bit about how this adapts over time to close itself off, open itself up, and actually adjust to the kind of very radical shift that occurs in the different seasons. So this is the operating system of the house. We're using MIT's processing open source software here to control, to have piezo sensors, so that as the wind blows by, different set of lights can appear. If you want to see a visual breeze, you can take the exterior weather and kind of pull it right into the house. So really what we're trying to look at is a kind of a diaspora of the envelope, a kind of unpacking of the singularity of the wall and its elaboration into a series of flexible layers. And we're trying to recover the kind of an exacerbated materiality of energy harvesting textiles, and a new spatial experience which could be moved and calibrated to different precedences in a very low carbon form of construction. So physically and performatively, the skins are reflective, and they also have the capacity to provoke a kind of rhetorical reflection around the particular contemporary cultural moment that we have today of infrastructure transition. Thank you.
Winka Dubbeldam, Professor of Practice, University of Pennsylvania. Hi, thank you for inviting me. I thought I'd today discuss some trash or trashy issues. I thought it was quite amazing to get invited for this particular
symposium or conference, since we're dealing with trash in my studio. Trash is not to be underestimated. Currently, we have 350 million pounds of trash circling the Pacific, which is only one of the gyres in the oceans. How does this thing work? Forward. Yes. Which is one of the gyres. Actually, every ocean has. Let's think of lights. Oh, what is the light here? Sorry. Got it.
But it's easier to change with those.
Thank you. So yeah, trash circles us, and trash is kind of getting very much the overhand. The thing about trash is that it's 80% plastics, and one little plastic bottle, the little ones over there, take 45 years to biodegrade. So even if it sometimes, and that is the most degradable plastic actually we have. So it's a really interesting future we're facing, and it was kind of an interesting coincidence that we are just looking at how to deal with this, and are looking at working with robotics institutes to see how you can collect that. And saying that, it's, as you can see here, this is actually trash as we know it. But the trash circling the oceans is less than 1 millimeter or smaller, so it is tiny, tiny, tiny particles. And the problem is that it became like in the middle of the oceans through rotation, through biodegradation, it actually has become a kind of, like, we call it a plastic soup. So the question is on how to get rid of this, because that same plastic soup gets absorbed with all kinds of things, and the problem is that our fish, especially whales, which are almost the only ones actually occupying that middle of the ocean, who sift plankton, actually now sift plastic. So it's an absolute interesting thing to look at. I think it's unavoidable to look at it, and it's urgent that we look at it. So that was my little trash story. And I think also that you can see here, this is actually when trash is still trash, right? Our coasts have a huge problem, especially in developing countries, or fast developing countries, how to deal with this. I mean, you might not see this, but this guy is actually trying to get through it. So yeah, there we go, plastic. Plastic is an interesting term, especially because I think for architects, and I think Galia gave a great introduction of the terms we go through, from risky to safe, from, I'm not sure about the ridicule part, but I'll talk to her about that later. That might be the Freudian slip. And the plastic issue, or the plastic term, is maybe the more interesting in the sense of that it is something which can be molded, and that the molded issue, or the idea of molding, has to do with behaviors, has to do with external pressures and internal circumstances. So this idea of constant adjustment and constant changing is maybe the most plastic in the way we think about plasticity. So we have gone in our little history, I won't go through the whole history, but a little history of work where we're trying to look at plastics or fragmentation as optimization, to see whether you can start to fold and bend materials, to get passive solar energy, to start to get a high level of opacity, to kind of diffuse membranes, to start thinking of new connections between exterior and interior, and privacy and public spaces. So this kind of constant research also goes then very often into plasticity as kind of a new way of looking at transparency, transparent stone, translucent glass, and the way you can research that and start to use maybe actually plastic mostly as a connective membrane, where we combine materials and we start to layer materials to optimize behaviors and performance of these new materials. So the kind of, and of course we know all the plastic qualities of poured-in-place concrete, where maybe something which is actually not that ecological responsible, but still one of the most easy kind of materials to work with as an architect if you want to think about space, spatial continuity, and plasticity. So I'll zoom into this project a little longer, because you're probably dizzy from the flickering images at this point. This project is one where we started working with, we work typically a lot with MIT Media Lab, as Sheila was also mentioning, which I think is really important for architects, not just to work with the MIT Media Lab, but to work in general with people like Anna, with MIT Media Lab, with engineers, and I think that's also why this conference is super important, is to kind of understand architecture much more as what we already are, is kind of a big team of people who are specialists, but to kind of cross-reference this specialism in different areas and to actually gain very quickly knowledge. So my trash story is also going back to that same issue, that it's really important that we work together with people in robotics, with people in science and technology, to advance both architecture, to advance spatial conditions, to work in developing countries like Sheila was working in Africa. So I think the idea here is we worked in this particular project with a friend of mine who has the largest independent car design company in the US. And we developed a series of facades from reclaimed wood, where we're kind of lucky that the facade width is exactly his robotic 6-axis CNC milling machine. And the facade can basically be milled with quite efficient methods in very, very little loss into this back facade. And of course, we're looking also now at ways, this is, as you might know, this is just a set of bumpers of car modules, to kind of look how you can optimize manufacturing in the way that we don't go back to the prefab idea of the 70s, but to kind of go back to ways of building things in clean workspaces, to have quick assembly times at our work spots or our construction sites, and to actually start to minimize trash. I think that's going to be a really important one. It's quite shocking to me to see how much trash we produce, but especially on construction sites, it's gigantic. And of course, the other thing is what we're all very jealous of is that our cars can open windows by just merely pushing one button, which I am still trying in my house and has never really worked. So this is then the technology you need for that, thing to work. So it's not exactly simple, but it's definitely something to think about. Like, why do we accept that our cars and our moving environments are very easy and very comfortable, and why is our actual living environment, where we spend most of the time, so far behind? So we do a lot of prototyping and thinking about how these materials can be optimized, how many hybrid solutions you have to come up with. And at some point where we started here actually thinking we had to incorporate steel, at some point we realized we could use that CNC milled wood facade more as a very, very large window. So to kind of take out most of the steel, only have the back connection of the steel to the actual building, and then use this all as a very, very large window. That facilitated a lot of things, one of which is, of course, that every material or different materials have different expansions, so it's a safer way to go. This was the first one with CNC milled, which is tiny. The other thing we're trying to do going back to the idea of plasticity, my constant attempt is to see facades not as separative devices, but as connective membranes. So here you start to see how different floors get connected and are more, maybe the space flowing through it is more plastic and is more connected than we usually get. A set of doors which are also made by the same man. And then a project we just recently finished in Shanghai is ports. Actually, the house you just saw was the creative director of ports. And after working on the house, they were basically, they were quite, I guess, quite happy. So they gave us all the port stores. The first one we did was in London, a very small shop-in-shop in Harvey Nichols. The second one is the large flagship store in Shanghai. And we started thinking that, you all know Shanghai. Shanghai, of course, is a large port, and what's quite interesting is that it has, this is the shop, it's on the Bund, it's right on the border, and that Shanghai has this amazing history of Art Deco. And Art Deco is an interesting, is one of the few interesting styles, I think, in architecture history, in the sense that it has moved from a very Art Nouveau, pastel, very soft kind of form of design into something which became quite futuristic and sleek. So it has had a beautiful transgression, and our idea was to kind of keep going in that transgression, to kind of extrapolate that information into the space. And we started looking at history of boats, recycling of wood, and seeing whether this idea of the liner or the organic shapes could be used in the space. So the first thing we did is we lined the space with this kind of CNC milled wood. Actually, Klein and I bought an old Chinese house where we used the wood for the walls to create a kind of an intelligent liner which contained all the space would need, which is air conditioning, lighting, hanging for the collection, vitrines, all that stuff. So, and then we were quite interested actually in the roughness of this wood and started thinking about the contrast of maybe what an oyster would be. So you have the rough outside and the very, very pearly inside. So here we kind of distinguished areas, which is the outside liner is more the showing of the collection. The inside is much more maybe gallery-like and shows, because this is their haute couture line, it's very much about pieces which are tried and ridiculed sometimes. And kind of how they themselves want to advance their fashion. So it's also where they actually show their new pieces and the way they want to start to rethink it. We also were interested in the way we can now create surfaces which give in to carrying things or supporting things or lighting things. So the small tables are developed to puncture the wood gives in, and the wood also then incorporates lighting, which lights these elements from below. And these are just the very first kind of shots we just got back. It just kind of finished. You start to see some of the elements, the units on the foreground where the lighting is incorporated. This is this is a little bit more yellow than it usually is, but all the lighting is LED. And it's kind of a very, very flowy space which starts to calmly give a background for the whole collection. Interesting is that we started to treat the wood only with kind of a silver dust to keep it completely natural and breathing, to keep it, and also as rough as possible. So there's kind of a contrast between the more smooth spaces. This is another fluid material which we know from the 50s, which actually is fiber reinforced concrete. So it's a material we use very little, and it's very easy because it's molded, it's very light, it can be made off-site and carried into the space. The other thing is that you can then reconnect the different elements seamlessly without much trouble. So it's actually, it's something, and also it's kind of maybe a rethinking of how we used to think of the old ceiling. So all these ceiling pieces are made with the same material. So it's almost like a secondary liner, but then a very, very, very soft one. Some padding. Padding is good. And then just to end, I want to show quickly how we thought of plasticity. And it's quite interesting. It was you might know the exhibit in the Guggenheim where they asked architects to look at the void and what to do with the void. And since our work is probably a lot focused around this idea of fragmentation through and how fragmentation could be optimization, we started to think whether that void had to be such a singular condition, or whether you could fragment the void and start to think of it as a much more connective tissue. And my movies didn't integrate, so there you go. So we started looking at unpeeling the voids, so taking the spiral of the Guggenheim, starting to pull it towards the middle and really plasticizing it. So the idea was to start to think of the plasticization as a kind of a form of creating new spaces, which would actually, in a way, show the Guggenheim as an art piece. So by now hovering in the middle, you look back at the Guggenheim, and the Guggenheim itself is an art piece, or from the Guggenheim, you would be the art piece. So it's kind of an interesting kind of moment where maybe this whole idea of museum can be turned inside out, and in a very interesting way, these kind of moments where we consider what is art, what's reality, and how we deal with that can be inversed. Let me see what I can go back to. Yeah. So basically, it's like this kind of idea of nesting in the middle, the moments that you can then occupy these nests and sit in the middle and see whether you want to enter the museum or not. It's a moment of hesitation, it's a moment of contemplation. And in a way, it would actually integrate the Guggenheim in my most, maybe if you could have a commentary on the Guggenheim, is the kind of idea of linearity and whether you could make this museum non-linear. So now you can take shortcuts, you can start to rethink how you want to walk and actually revisit the whole idea of the Guggenheim. Thank you.
William Pearson, Technical Director, North Sales, One Design International.
Good afternoon. Most of the heavy lifting seems to have done this morning, so welcome to the entertainment part of the seminar. Graciously organized by Michael for your pleasure. As sailors and sailmakers, we have somewhere between little and nothing to do with architecture per se. However, we're all about design for composites and the efficient use of appropriate materials. So when a sail designer begins a project, he needs to take into account form, materiality, process, and structure. And if he doesn't integrate those four components into the project at the beginning, it's going to go pear-shaped on him before he gets to the end. And this is a way of sort of stating explicitly what Greg Lynn was talking about implicitly last night when he was talking about using all those components, needing to use all those components of composites at the design stage, or else you're in danger of moving into sort of Greg's composite tectonic nightmare, where you've got a sexy curvaceous carbon fiber structure and you're screwing or bolting cladding onto the outside of it. So in this photograph right here of a 105-foot race boat, which I sail on frequently myself, I'm back there in the corner. Everything in the picture, with the exception of the white nylon spinnaker out the front of the boat, is a composite structure. So the hull is a carbon fiber composite structure, a sandwich skin structure with a foam core. The mast is a monolithic, one-piece carbon fiber structure. The sail is a flexible carbon fiber composite structure. And even the lines, which we call stays and rigging in the marine industry, are fibrous materials, PBO, and increasingly now carbon fiber as well. So as most people at this conference would understand intuitively, for performance sporting applications, composites are absolutely the norm. In fact, it's increasingly rare that anything made for maximum performance would be made out of anything other than composite materials. And the reason is simply that in performance sport applications, there is an insatiable demand for increased stiffness and lighter weight, basically at the same time. So the generational cycle for products in the sporting industry, be it motorsport or sailing, is basically a one-year cycle. So both the participants and the clients or sponsors expect their Formula One race car, their new racing sailboat, or the new carbon fiber sail next year to be at least marginally stiffer and lighter than the ones they had this year. So there's this constant pressure in our business for performance, which drives a willingness to be innovative. It drives us to be early adopters of new materials and process, and to some degree forces us to take probably more risks than would be acceptable in your business. So modern sails are made using computer-controlled robotics to achieve bespoke fiber placement on large articulating curved molds or tools. Traditionally, sails were made from woven materials, and that's a photograph from the deck of the racing sailboat in the first picture as we sailed through a fleet of boats that are over a century old. So traditionally, sails were woven materials, materials made in textile mills as roll goods, comes out to the sail making factory on a roll. Panels or sections are cut off the rolls, they're shaped individually, and then they're assembled mechanically. In areas of the sail where you need either more strength or more modulus, the method used was to apply additional layers and stack them on top of each other and fasten them mechanically to the surface. So in textiles, stitching is the method of mechanical fastening, the dreaded nuts and bolts of Greg Lynn's dreams. And, you know, most things are thus or were thus. So performance sportwear, and to one degree I'm amazed that we've been molding sails in one piece and many hundreds of square meters at a time in bespoke shapes, but as far as footwear goes, we're still fastening things together mechanically. So the bed is actually a one-piece molded structure, and it's fairly sophisticated. There's a number of different colors, 3 different colors of rubber in there, and at least 2, if not 3 different durometers of rubber, all molded in the same, one time in the same injection molded process. So reasonably sophisticated and very commonplace. However, the upper part of the unit is still mechanically fastened. So you got a surface that's next to the skin. In any place you need additional load holding capability or torsional rigidity, you fasten on straps mechanically. So in the sail-making business today, I refer to what we produce as flexible composites, which is traditionally a little bit of an oxymoron. Composites are normally thought of as rigid structures. So in our flexible composite world, the item is manufactured with composite materials, plastic materials, using the same processes that composites are manufactured in. However, the finished item has some textile qualities. It's still flexible and foldable. As you can see in these all carbon fiber sails here, there's different fiber orientations and trajectories across the sail plan. The greatest fiber densities are clustered in the corners from where loads are reacted on sailboats. This boat here is, I think, 160 feet long. It's about a 240-ton boat. The surface of that sail there is about 450 square meters, weighs maybe 1,000 pounds. Out here in the lightly loaded area of the sail, in the more lightly shaded area, the membrane is about 2 millimeters thick. Down here in the corner, there's a concentration of fiber and resin that's maybe 35 millimeters thick, or an inch and a half, let's say. And all that fiber starts in the corner, fans out across the body of the sail. And that's the most highly loaded part of the sail there, which we call the clue corner. And the safe working load on that corner is probably in the neighborhood of 20,000 pounds. Modern sail design starts with a finite element analysis of a particular sail geometry. A sail designer uses this to determine what the fiber strain is going to be and where he needs to place fiber, what locations in the sail, and in what densities. There's a view of a relatively simple fiber architecture on a small racing sail. So this is a one-piece molded sail here. You can see that the fiber orientations in a modern sail are asymmetric, and asymmetry is efficient both in terms of performance and in terms of material economy. And I talk about asymmetry in sort of opposition to the formal symmetrical microstructure of a woven textile, where you've got the same material, same amount of material across the surface, whether you require it for your structure or not. It's there because of the way the material is manufactured, not because of the way it's necessarily used. So again, in a modern sail, we place the fiber in anticipation of the wind loads and the variations in the stress field as the boat moves through the waves. So varying orientations and densities allow us to optimize locally for strength and stiffness. The process allows us to put fiber in the sail only where it's required on an as-needed basis, allowing us to make the lightest possible structure for any given application. So in this scenario, material economy is a win-win-win. Material economy is good for performance because a lighter structure is better. Material economy is good for cost because if there's less material, the structure costs less to manufacture. And material economy is, of course, good for environmental reasons as well. There's a photograph in our shop of the way modern sails are manufactured. So they're manufactured horizontally in the shape of a wing, effectively, which is what a sail is. It's a wing on a boat. So this is an adjustable articulating male tool. We change the shape of that on a bespoke basis, sail to sail. Fibers laid from corner to corner, uninterrupted by any seams or joins. So in this method of manufacture, there's no longer any distinction between the sailcloth and the sail. So effectively, as Jan was talking about this morning, the material is being manufactured at the same time as the finished product is. Visually, there's some distinction still between the surface and the structure. However, the surface and the structure are made together and they're inseparable. One can't exist without the other. So this is a shot end-on of one of our adjustable articulating molds. This is the surface up here, which is, we change the curvature or the shape of the surface with this pantograph lifting mechanisms here. And the surface is adjusted on a bespoke basis, sail for sail. So this is mass customization in practice. The process is the same for every different sail, but every different sail has a unique structure, a unique geometry, and unique aerodynamics or shape. It's an underview of one of these reconfigurable tools. This platform is 48 meters long, I think, by 19.5 meters wide. So it's a total surface area about 500 square meters. There's 240 lift points underneath this mold, and each one of these pantograph lifters is attached to a vertical screw here that's driven by 2 pneumatic actuators. So 2 pulses from each actuator is one 360-degree rotation. So the accuracy in the Z direction in vertical space is a quarter of a rotation of that screw. So it's effectively inside a millimeter, which is pretty accurate for such a large platform. You can kind of see underneath how fair the surface is for such a large tool. It's an overview of our shop. So there's 11 molds or tools of varying sizes and geometries. These overhead gantries run the length of the building to service the molds. One gantry services 2 molds. Off the overhead gantry, there's a robotic arm that moves in the Z direction, and on the bottom of the arm, we attach different tools used in the manufacture of the sails. The most important tool being the fiber placement head there. So it's a 6-axis PLC-controlled head that lays down the fiber architecture. So the head follows the 3-dimensional curvature of the mold, and draws a pattern in yarn reflecting the anticipated loads in the sail. You can kind of see an end-on view of the fiber matrix there. There's a corner of the sail, so the greatest density clusters. The fiber fans out across the body of the sail along basically catenary curves. And then we build a vacuum bag around the laid up materials, just like you would do with any other composite part. Draw 1 atmosphere of pressure, and in our case, we heat up the laminate to about 300 degrees Fahrenheit in order to flow a thermoplastic adhesive. And when you're done, you pull off a one-piece flexible structure that's got the shape of the sail molded in. So the shape that the sail's going to have when it's up on the boat and pressurized is set permanently into this flexible laminate. So this process is roughly 20 years old now. So for the last few years, we've been working on what we're hoping to be the next generation. In our business, we're all about what I call better use of existing materials. Sail design is modulus driven, so you're in a constant pursuit of trying to find a way to get more effective modulus in your membrane using the materials that exist at hand and that everyone else can use as well. So the structures that I've showed you photographs of being built, we call those load path structures. So we're laying down fibers, yarns or fibers or tows, which are in fact bundles of filaments. So what you think of as a single yarn or a carbon fiber tow is a bundle of 3,000 or 6,000 or 12,000 individual filaments. The mechanical properties of the filament are actually superior, particularly in stiffness or modulus, to the mechanical properties of the complete bundle. So there is some efficiency to be made if you can use sort of the base material of that filament instead of use it in the bundle form. So the philosophy here is to take that bundle, break it down, and lay the filaments out side by side into a tape. So it's the same, in this case, it could be the same amount of filaments that are in the yarn, but it's spread out side by side into the tape, and it's pre-impregnated with resin. So in the rigid composites business, this is called a unidirectional pre-preg tape, and it's nothing new. It's the way that all sophisticated high-performance carbon fiber structures are made. But it's new in our business because no one's ever done this with a flexible membrane before, and we're making a lighter tape than is available anywhere commercially because of the demands that a sail be light and flexible. So in our case, instead of using epoxy matrix, we're impregnated it with a really high elongation polyester thermoplastic. And because these materials are so gossamer, they're almost impossible to handle, we had to develop, along with the material, the means to deploy the material. So there's a ATL system, or automated tape laying head. And we deploy the materials into sections. Despite the sophisticated nature of most composite structures, with the exception of places like Boeing and Airbus, almost all composite structures are still laid up by hand. So there's people laying over molds, putting in individual layers of material one at a time, hand by hand. It's very, very labor intensive, which is one of the reasons why carbon fiber structures are so expensive. So we're intending to automate this as part of our process. And again, so we're going to plot down different orientations of tapes, different densities, and in the composites business, this is called a preform. So we're going to take this preformer section and move it over in one piece onto our adjustable molds and build a vacuum bag around it and laminate it just like the other parts of our process. So I'm being told to wrap up here. So very quickly, this is a photograph of an America's Cup race boat. It's got one of these fiber composite sails, the head sail on the forepart of the boat, and one of our load path 3DL sails. as the F sail in the background there. So an important aspect of this new sail is there's no longer any film or any substrate in the sail. So this sail is only a matrix of fiber and composite. And as such, the traditional distinction between structure and surface now has completely gone away. The structure and the surface in this sail are completely one and the same. They're inseparable, and you know, you can't even discern the structure anymore as you can here. This is a load pass structure, and this is what we call a quasi-isotropic structure. And the surface and the structure are completely integrated. And I won't dwell too much on this because Greg showed it yesterday. The interesting part of this for me is the structure exists somewhere in the intersection between a composite and a textile. You know, it's formed like a composite. It's built with composite materials. It's built using composite process, but it's you know, somewhat flexible. You can fold it or roll it. And as Greg was saying, in static mode, it's a compression structure, and then when it's loaded, it kind of turns into a tension structure. And again, that's part of the quasi-isotropic nature of these materials. Very quickly, this is a process we're not using anymore, but I thought it might be important to show here because the scale is so important in architecture, much more important in our business, and I wanted to show potentially some of these things could be done on a much larger scale. So this is, this drum turns, we call this rotary molded sails, and all the processes we were doing in sequence on the horizontal molds, we're doing simultaneously on this drum as it turns. So the materials are being fed in one end of the drum. The surface of the drum is, I guess maybe that means I'm done. Can I get that back? So you can see the fiber placement heads here are moving horizontally across the surface as the drum is rotating. The surface of that drum is actually being deformed into an aerodynamic shape, just like the surfaces of those horizontal tools you were looking at. And fibers being laid down directly on top of that deformed surface. And it's kind of a look at that drum. It's 12 meters long. And those holes in the barrel of the drum there are being used to fire pistons through from all these pneumatic actuators. So there's 2,600 actuators inside that drum that fire pistons through and deform a surface into an aerodynamic shape, continuously changing it as the drum turns and as you're feeding materials into it. So raw materials go in one end, and out the other end comes a string of individually shaped bespoke sails that are attached and then sliced up and removed from the drum. Okay, so I'll finish there. So I probably don't have time for my 4-minute video. Highly entertaining. But thank you.
Thank you so much. Our other sponsor for this conference is Time. And time is not as generous as the Vinyl Institute. And in the interest of time, we have to go on to the next panel. We were very ambitious. Michael and I batted this back and forth. How can we do all these panels in one day? So many brilliant people, so many amazing ideas. We're trying. And we also do have a venue change at the end of the day, and our film crew, which is amazing, has to get their equipment over there, so we can't go too much later. So I'm going to pass this on to Michael. Are you going to say something? Yes. Michael will say something, and then Brian Kane will come up and introduce the next panel.
I did want to just say one quick comment. We are not managing time as well as we would like today. However, everyone is here. It's been remarkable. There is a book that comes out of this conference that will indeed produce a second wave of conversation. So for those of you that are looking for the conversation. However, the speakers today, I hope if you're still here, perhaps the conversation after this panel will allow us to elude back. I will now, I think the audience and the speakers are going to reconvene for this panel. The moderator for this panel will introduce the speakers who frankly need no introduction in this building. The moderator, however, could use an introduction. His name is Brian Kane. He is an assistant professor of music at the Yale School of Music. Brian was a postdoc at Columbia in the School of Music, specialist in composition, and is, in fact, a specialist in some very experimental forms of composition and art music theory. So this will take a minute while the tech crew reconvenes this group of speakers, and we'll ask Brian to introduce the speakers and make an introduction. Thank you. It's like guitarists who bring their own guitar. Nobody's happy with our computer.
Just put this. And here we go. We're done. You can go ahead.
Yeah, just 1 minute. Check everything.
You will be mine.
You have a light?
For the lights.
How do you guys read
I guess I have that light.
in your face instead of on the thing?
Just an arrow, yeah.
I think that's the light. No, there's that one. That'll work.
Right, but it's there.
What's going on?
Well, we have to organize the light, right?
Yeah.
Yours is what, plastic wheel?
It is?
Yeah, so it's loaded, yeah. Yours is loaded?
Okay, so if we are using the computer of the school,
Yes,
how do we
if
pass
you're
the
using
how do you pass the images?
just these two.
Okay.
So they'll put yours up when you come up. You don't have to worry about the mouse. Just these two. And if you want the pointer, it's the red button.
You want the point? Is this one?
Right there. So you're going to bring our PowerPoint up. You're going to need to do this.
Yeah, your PowerPoint is want to do another one first?
Or I better copy this file into
Okay.
PC and then
Let's do that.
Well, but we have.
You have Felicity already.
Yeah, we have Felicity.
Felicity.
Some technical problem. Can you do that? Yes. Okay.
Okay. Felicity will go first.
Okay.
Thank you for bearing with us. Let me reintroduce Professor Brian Kane.
Great. Thanks. All right. We really have a kind of all-star panel on the question of plastic as a cultural material and a countercultural material. Coming from the discipline of music, not being an architect myself, I figured I would take the opportunity to kind of briefly reflect a little bit about a constellation of terms of plastic, music, culture, and counterculture, and how these things might relate to one another. I'll give a very kind of quick exposition. I feel like I'm under some kind of obligation to represent music, so I'm going to do it. Music has a kind of odd relationship with the plastic, I would say, in the sense that when theorists of music like myself often talk about something like musical material seems to have something like plastic qualities about it. It seems to be a kind of material that is endlessly evanescent in the sense that it's coming into being as it's disappearing. It's moldable, it's shapeable, it's manipulable. It's also inexpensive, in the sense that we have an endless supply in the composer's imagination and the sounds that are produced in the artificial and natural world. Musical forms and the schemata that underlie musical composition tend to be organized or tend to involve processes of deformation in many of the same ways that plastic does. We take models that are out there and we continually shape and mold them in all kinds of different ways. I mean, perhaps the musical notion of plasticity is much more related to the older Greek notion of the moldability of material, the Greek notion of the plastic, than the particular material modern 19th and 20th century notions of the plastic. But those, and there's one other thing to mention about it, is that often this kind of plasticity of musical material allows for something like a musical transcendence to occur. Because musical material is so malleable and so evanescent, the thing that imbues it with life is often considered to be a kind of transcendent substance or spirit. When we start to look at something that is quite literally plastic in music, we can find kind of interesting moments where the plastic appears and it becomes a kind of, it has both the possibilities of doing cultural work and countercultural work. I want to mention two instances. There's a famous 1953 instance, a famous concert, Jazz at Massey Hall, Charlie Parker, Dizzy Gillespie, Charles Mingus, Max Roach, where Charlie Parker played not only his famous white plastic mouthpiece, which is iconic if you've ever seen Clint Eastwood's film about Charlie Parker, this white plastic mouthpiece is in every image of it, but he also played a plastic saxophone. And jazz connoisseurs love to make a lot of hay out of this, saying all kinds of, you get the ridiculous cliche that often says, well, Bird was so great he could play on a piece of junk and it would sound amazing. And the logic of that kind of statement is basically a recuperative logic, right? It's an overcoming of the material in order to produce something like musical transcendence. In a certain sense, you get a very old aesthetic of music that's reinscribed in that kind of utterance, kind of aesthetic of music that's very much like what Hegel thought about music, requiring the kind of very minimal conditions of materiality in order to exist. You can also think of a countercultural moment like the moment when Ornette Coleman arrives in New York City. Ornette Coleman, who's the great free jazz saxophonist, also played a plastic saxophone. It became a kind of indexical thing with him. I'm thinking of the cover of the record, The Shape of Jazz to Come, where you see him actually holding this plastic saxophone. And something about the strangeness of his sound is inscribed in the fact that he played a plastic saxophone. His music, which seemed to come out of a sort of, it came out of a bizarre route, not out of the mainstream of jazz, is somehow indexed in the kind of weird plasticity of the saxophone. But of course, the most important place where one sees plastic emerge in music in the 20th century is, of course, the vinyl record. Right? In fact, I can think of no other situation than the vinyl record where plastics are perhaps so fetishized, right? and so ubiquitous. In fact, I think about the living room of every American house, and especially the kind of bedroom of every American teenager, at least of a certain period of the 20th century, that has this stockpile of vinyl discs that are covered with images and inscriptions that have their own kind of aesthetic properties, right? They're not simply places where music is inscribed. They're not simply containers like an MP3 for holding information. They themselves have their own material properties that are not often thought about. The vinyl disc, vinyl is something that sounds better than shellac. It ostensibly has less surface noise, which is one of the reasons that recommends it. It's durable. It could be sent in the mail. One of the interesting things about the vinyl disc is that it's essentially a transparent piece of PVC that's given carbon black in order to make it black. That black has its own aesthetic properties. Everyone knows the image of looking at a vinyl disc and seeing those two kind of refracted light beams, coming off in either direction. What's interesting about the carbon black that's added to this PVC in order to make a vinyl disc is that it itself has magnetic properties that attract dust to it. So a lot of the rituals that are involved, this kind of fetishized rituals that are involved in cleaning and dusting off records, are part of the material of the record itself, right? The dust that's attracted to it ends up somehow bringing out the materiality of the disc, right, in the guise of something like surface noise. So the vinyl disc is probably, I can't think of really of a kind of parallel of where plastic has become so imbued with things like the formation of identity, the rise of a certain kind of cultural form of distinction, cultural knowledge. It's kind of amazing site for so many places of musical meaning. I can't even count all the kind of things that are happening at that side of the record. We're going to move on, though, and not talk about music in the rest of the panel. We're going to be talking about architecture. Maybe we'll come back to it. We're actually having a slight change of plans. We're going to begin with Felicity Scott, and then we'll move on to Hernan Diaz-Alonso. But I'm proud to introduce Felicity Scott, who is the director in the program in critical, curatorial, and conceptual practices in architecture right here at Columbia's GSAPP. So Felicity, welcome.
Thank you. Yeah. Can I have the first slide, please? So I guess it's flashback time to start. In March 1968, critic John Perot reported on the recent work of Irish-Canadian artist Les Levine in Art News under the title Plastic Man. Mild-mannered, soft-spoken Levine, wearing his horn-rimmed glasses, he began, steps into a telephone booth, orders a new plastic dome, and everyone is infuriated. The reference, of course, was to Laszlo Moholy-Nagy, who in 1947, or in the 1947 edition of The New Vision, famously claimed to have ordered the fabrication of a set of enamel on metal paintings in 1922 by dictating instructions by telephone to a sign manufacturer, each party equipped with a piece of graph paper and an industrial color chart. Forging new stakes for artistic engagement with industry by staging withdrawal of what he called the individual touch, Moholy-Nagy insisted that the manufacturer on the other end of the line had executed the so-called telephone paintings entirely in his absence. 45 years later, it seems such mediation by telephone was no longer critically in alignment with such heroic modernist ideals. Perot noted the irrational fury and defensiveness provoked by Levine's work, as manifest in statements such as, Les Levine is a science fiction artist out to destroy Western culture. He proposed that the key culprit was plastic, which, as he explained, had negative overtones, plastic people, plastic food, etc. Since his discovery of industrial vacuum and pressure molding techniques, Perot reported of Levine, he has worked exclusively in plastic. By 1968, Levine had not, in fact, worked exclusively in plastic, a detail Perot alluded to in referencing the artist's non-apologetic use of technology, such as television and computers, as well as print-based media. Yet something about the artist's engagement with the plastics industry, and hence with a material so identified with mass consumer culture, had, it seems, resonated uncomfortably with conventional claims regarding the contemporary role of artistic practice. The work revealed contradictions at play, that is, both within long-standing modernist tropes like truth to materials, and of course the benefits of collaborations between art and industry, as well as within avant-garde pursuits of the so-called dialectical sublation of art into life. So here it seems was a too comfortable fit. And moreover, these uncomfortable resonances, I want to posit, might have something to say in turn about the object of my own discipline, that of architecture, as it encountered a similar nexus of historical forces at this moment. So to unpack the nature of Levine's provocation a little further here today, I want to begin by looking at his work from '68, as Perrault read it, before turning back to the previous year and in turn to his shift away from plastics to electronics, or really, as I want to propose, a type of desublimation of that. And this is really new research, so that some of the images are a little challenged. Plastic Man Strikes appeared on the occasion of a one-man show at the Fishback Gallery in New York. The announcement for the show read, "Caution, some plastics may be hazardous to your health." Levine presented two plastic works in this context, Disposable Walls, and I don't have an image, but I have an image of Levine disposing of his art, and The Clean Machine on the right. If the former exemplified his ongoing project of mass-producing cheap, quite literally disposable art objects that would be thrown away by the collector once their aesthetic effects had worn off, the latter exemplified the other primary modality of his work, that of the production of environments, or what Perrault referred to in this context as epistemological environments. The disposable walls took the form of 8 brightly colored, satin-finished, vacuum-formed metallic butyrite plastic units, the shape of which was reminiscent of refrigerators. Levine posited in his press release, and these were actually works for him, conceptual works, that his disposable walls were conceived as anonymous objects to be arranged in sequence by the purchaser to his own specifications. And he later noted that Philip Johnson bought an entire wall. The Clean Machine, the press release explained, was composed of 60 plastic units with a glossy white finish, ready in this image, white finish arranged to form a passageway around the perimeter of the gallery space. Each of the plastic forms is 4 feet wide by 6 feet high by 18 inches deep at the point of greatest projection and is made of pressure-formed UVEX, a cellulose acetate butyrate plastic. I'm concerned primarily with the making of a work not entirely reliant upon visual devices, but also a work that is physically experiential, he explained, and he continued in a manner reminiscent of Walter Benjamin's famous account of architecture being received in a state of distraction. And I quote, "I want the work to be free of visual references because they're related to the idea of contemplation, and I want a work that one can experience as one goes through it without having to look at it. The spaces in the piece are constantly opening and closing as the spectator passes through it, so that one is constantly being physically reminded of one's own size, how one walks, and how one's senses react to space." Perrault also reviewed the exhibition for the Village Voice, and this is like the only photograph we have of this installation. Perrault also reviewed it for the Village Voice under the title Plastic Ambiguities, in which he noted that when walking through this distinctly non-static space, nothing seems to happen. And I quote, "It's only after you've walked through the glistening corridor of the Clean Machine and come out the other end in perhaps 2 minutes flat that you begin to realize that something very perplexing just happened. All the modules are exactly the same, and so there's no reason to stop and look at any particular one of them. They are too close, in fact, to allow you to stand back and take a reading. They protrude almost dangerously and combine a cold, hard look with an illusion of softness created by their surface reflections. This forced perspective, created by these trapezoidal protrusions," he goes on, "pulls you along at breakneck speed through this almost featureless circular maze. In a work that on the surface seems very simple and very empty, Levine combines several different ways we have of reading space and lets them rub up against each other and contradict each other in a way that is new and almost completely successful. The trapezoids describe the single-point perspective used in traditional drawings, except here the vanishing point is continually elusive," end of quote. So then, after noting that this high-speed walk, as he called it, prompted him to walk through its passageways 5 or 6 times, trying unsuccessfully as it turned out, to grasp what was causing this effect, Perrault concluded of its exhilarating impact. "All I know is that I found myself wishing that I could take off all my clothes and walk through it naked to get the full charge of its ambiguous tactility." So in a landmark 1968, this is one of the press releases. In a landmark 1968 Art Forum essay on the post-formalist art practices entitled Systems Aesthetics, Jack Burnham situated Levine's Clean Machine within an artistic lineage traced from Moholy-Nagy telephone paintings through Ed Reinhardt's black paintings, Donald Judd's concept of specific objects, Robert Morris's L-beams, as well as actually Morris's steam pieces and recent earthworks, to Carl Andre's modular floor pieces. The very scope of such systems-based work, Burnham argued, necessitated interdisciplinary or refusal of boundary concepts through which modern art had operated. Consequently, as he put it, some of the more aware sculptors no longer think like sculptors, but they assume a span of problems more natural to architects, urban planners, civil engineers, electronic technicians, and cultural anthropologists. And it was at this point Burnham returned to Levine, whom he referred to as methodologically the most consistent exponent of a systems aesthetic. Levine's clean machine has no ideal vantage points, he went on, no pieces to recognize as are implicit in formalist art. One is processed, as in driving through the Holland Tunnel. Certainly, he goes on, this echoes Michael Fried's famous reference to Tony Smith's nighttime drive along the uncompleted New Jersey Turnpike, yet if this is theater, as Fried insists, it is not the stage concerned with focused upon events, end of quote. In addition to having moved beyond these so-called boundary definitions circumscribing conventional art mediums, Burnham noted that Levine's visual disengagement extended to the point where, and I quote, in a recent environment by Levine, rows of live electric wires emitted shocks to passers-by. Here, behavior is controlled in an aesthetic situation with no primary reference to visual circumstances. As Levine insists, and he quoted, "What I'm after here is physical reaction, not visual concern." So the work, entitled Electric Shock, as you see here, was indeed intended as an extreme case of an artwork confronting the beholder, a work existing only through the participation of the viewer in a quite literal sense. As Bourdon argued in a Life magazine feature on Levine, this place consists of a completely bare room equipped with a row of overhead wires creating a false ceiling a few inches above the spectators' heads. At regular intervals, a high-frequency generator charges the wires with electrostatic energy, giving a jolt to any spectator who happens to touch them, as well as anybody they happen to be touching. People are drawn together or apart because they can hold hands and get a charge from one another. So running concurrently with the Fishback Gallery show was a second related exhibition of Levine's work at the John Gibson Gallery, a sort of retrospective of earlier plastic pieces in miniature, albeit now, and this is actually one of the pieces that is in model form in the show, I just don't have an image of that, albeit now rendered somewhat allegorical in the model form. It included 7 scale models, including comprising his star series, 3 of which indicated new possible arrangements of these clear plastic bubbles, the other 4 recalling earlier exhibits such as the Star Garden, a place at MoMA, All-Star Cast, installed, as you see it here, on the Americas Plaza of the Time and Life building, the Star Machine, and Primetime Star. So I want to return then to these projects of a couple of years earlier, the year before, but coming back to this question, before coming back to the question of what motivated a work such as the Electric Shock, with its even more exacerbated suspension of the observer within a matrix, or as he put it, a system of information. The modules for the Star series were fabricated using a distinct technique, and unlike the Clean Machine, transparency was key to their operation. So take, for instance, the Star Garden, a place installed on the upper terrace of MoMA's Sculpture Garden. Covering an area of 40 square feet and standing about 7 feet high, the work was comprised of 4 sets of 4 modules arranged to form bubble-sided cubes, each mounted on aluminum uprights with 2-foot aisles between them. With materials donated by the American Cyanamid Company, the Building Products Division, each bubble derived from a clear acrylite plastic sheet that, as his press release explained, had been heated and then shaped by jets of air into rounded forms. Levine, it noted, referred to the work as an architectural device. As with the Clean Machine, the artist insisted on the primacy of viewing, explaining, and I quote, "Since the piece has no importance without people, the viewer enters and becomes the star. The piece is concerned with physical experience, not visual contemplation. It has no validity until someone is inside it, not simply looking at it. The work is almost invisible, intentionally. The viewer is more aware of his own physiognomy and of the people and objects outside the Star Garden, not in a visual way," he kept insisting, but in a sensory way than of the piece itself. It is intended literally as a place to be in rather than an object. It packages people in endless space and makes them look more beautiful, shiny, and new. So critics repeatedly mused over the fact that the bubbles were not the product of the artist's hand. Recalling Moholy-Naj's earlier claims, the artist stated, "I simply phoned up the plastics company, told them to make 16 sheets of acrylite plastic and free blow it to the size I wanted, and a few other technical details. I never went to the factory. 5 minutes over the phone was all that was needed. I never touched my work." Nowadays, all the artist has to do, he explained, is think about the piece and tell the proper person what he wants. The artist's real function is to conceptualize. Such a hands-off approach to fabrication of a work was, of course, to point to the obvious perhaps, entirely familiar to architects, whose practice consists not of making buildings, but in conceptualizing them and producing instructions for them. Key to the physical experience, then, of physical reaction provoked by the Star Garden was a feeling, as Levine explained, of weightlessness, or what he called the sensation of your body lifting up and down. Interviewed for Art in America, the artist began to offer a small clue as to what might be at stake here, noting people stretch their hands out since they don't know where the edges are. They can't feel boundaries, and yet they know there's some kind of restraint. On the 2nd of July in '67, Levine and his Star Garden appeared on WCBS TV in an hour-long broadcast entitled "The Walls Come Tumbling Down." Speaking with Levine, commentator Leonard Harris referenced the notion of breaking down the wall between yourself and the environment, and Levine responded of his Star Garden, "It also has the effect of bringing you the information immediately surrounding, in that if you look at it as you pass by, you see the buildings that are the surroundings. So what you get," he explained, was the sensation of your own physicality plus the information around you. And you get a funny sensation because for the first time in your life, you see yourself moving in the environment in which you really move. That is, right from these earliest works, the phenomenological dimension of reception was always and already understood to be inscribed within a perceptual and conceptual matrix derived from another information paradigm, the work that is aimed to produce the experience of time-based media like a closed-circuit television, but without the affiliated equipment. In addition to the art press, just to point out quickly, the Star Garden garnered significant chemical industry coverage, being referred to by customer relations manager for American Cyanamid, Tom Bross, as an attractive exposure vehicle for acrylite, since it demonstrated the material's key properties, and he listed these as toughness, weatherability, formability, light transmission, and clarity. So that is to say, with plastic, the old modernist adage of truth to materials made smart business sense as well. So while the Star Garden was on view at MoMA, Levine was installing another, and to many observers, more psychedelic environment, or the plastic environment, at the Architectural League, where he served as vice president of sculpture. Previously exhibited in a slightly different configuration at Toronto's Art Gallery of Ontario in 1966, and with its appearance at the League timed to coincide with the National Convention of the AIA, Slipcover, as it was called, took the form of a plastic environment, the floors, ceilings, and pulsating walls of which were covered with what was called microbright or mirrorbright, a mirror-finished metallized polyester film that was supplied by Coatings Products Incorporated of Englewood, New Jersey. When you tire of it, the artist explained to Rita Reef of his use of this shimmering synthetic fabric to create what he called disposable rooms, you just rip it off and throw it away. As Levine noted when interviewed during the installation of the project in Toronto, a slipcover is a very common object which is used by most people to change their world. And this one too, like those slipped over a piece of furniture to give it a new surface, could be removed and replaced by another. The most detailed account of the spatio-temporal topology of slipcover, with its mirrored surfaces, projected images, and so-called air erections, was set out by John Perot for the Village Voice. The mirrorbright, he explained, dissolves, conceals, and expands the actual space involved into a labyrinth of shiny textures and reflections. It's like being inside an iceberg that has no top, bottom, or sides. Slide projectors bounce colors and subliminal messages or images off the mirror-esque surfaces and increase the spatial dislocations brought about by the billowing breathing bag forms that are inflated programmatically by concealed rotary blowers and alternately expand and contract the space around them as they themselves expand and contract, at times almost filling the rooms and forcing the viewer up against his own reflection. At once evidently cool and calculated while strangely organic, in Perot's terms, and I quote, "The effect of these dazzling vinyl-scented explorations of synthetic materials, concealments, and space manipulations is eerie, fascinating, and coldly beautiful. It's like a cave of crystal that hovers dangerously between a beautiful daydream and a crazy nightmare." Levine insisted that visual and audio feedback was in fact the most important aspect of the work, suggesting that it creates extended human consciousness in the same way as sophisticated computers. The computer system, he goes on, is based on memory, and the computer extends its own memory by the feedback of information it produces. The simultaneous vision of what was there and the immediate memory will create a scary sense of reality, which is more than real. So in this, he was referring not only to the closed-circuit television elements that few of the viewers noted. In addition, we can say, to a reorientation of temporal structures on the uncanny exteriorizing of memory, there was another, more trippy dimension to this cybernetic experience, a sort of melting into the environment, familiar, of course, from psychedelic literature, that was born of the reflective plastic itself. The use of plastic, that is, aimed to mirror the subject's dissolution into technological systems through the viewer's integration within the information environment. The plastic resulted from Levine's own industrial research, it might be pointed out. It was developed from formula he evolved himself at research at Kodak, and it had been especially made for him in New Jersey. So as the artist explained of its intended qualities, the shiny surface is not only clean and precise, but it attaches itself to you. It draws you into it to some degree. Reflective things, shiny surfaces, do attach you to them in an abstract way. Even though you're across the room from them, you still have some rapport with them. Levine seemed happy with the outcome. As reported in the Toronto Globe, the artist, wearing himself a reflective suit, watched with great pleasure. And I quote, "Oh God, isn't that fantastic?" he said. "You see how it doesn't need me anymore. It has a mind of its own. Everything there has its own feedback. It's just like a computer. The more information you give it, the more it feeds back to you. You just can't keep up with it." So 1968 was in many regards a watershed moment for the art world's engagement with plastic, even marking its apotheosis. Levine's work appeared in 3 major group shows that year, actually that year and the next one, addressing the material, or as was repeatedly suggested, the new medium of plastic. In October 68, Made of Plastic opened at the Flint Institute of Art in Michigan, appearing alongside Andy Warhol, Paul Thek, Hans Haake, Robert Morris, Louise Nevelson, Klaus Oldenburg, Donald Judd, Eva Hesse, and other artists. Levine presented Mini Star. The following month, the Museum of Contemporary Crafts in New York launched Plastic as Plastic. In addition to works by artists, it included works categorized as architectural applications, furniture and interior accessories, housewares, packaging, historical like Bakelite, as well as technological applications ranging from laboratory equipment, medical syringes, portable toilets, electronic equipment, and prosthetic body parts, as well as toys. In this context, Levine's disposables appeared not only alongside other mass consumable disposable artifacts, but also in the company of experimental architectural works like Haus Rococo's Room Scraper, also the Balloon for Two, and the Yellow Heart, model of Yutaka Murata's project for the Fuji Group Pavilion at the upcoming Osaka Expo, Arthur Quarmby's inflatable domes on the right, produced for the set of 20th Century Fox film, The Touchables, Ugolo Pietra, other stuff, and of course, Surinam's Futuro House. There's also things like Felix Drury's experimental foam house that he worked on for Union Carbide. Finally, a plastic presence opened in November '69 at New York's Jewish Museum, an exhibition attempting to address, or really to sort of redress, the way in which plastic confounded conventional notions of a material or a medium specificity. Both the material, of course, and the optical properties of plastic could be designed, color, transparency, toughness, ductility, diffraction qualities, etc. Among a much expanded group of artists, notably, I might point out, including many women, again, Nevelson and Hesse, also Helen Pashgan, Susan, Louise Williams, Sylvia Stone, and Vera Simmons, Levine presented what he called body colors. sending in a photograph for the catalogue which depicted him on the telephone. Body colours would in many regards be Levine's last major plastic bubble work. It took the form of an approximately 60-foot-long walk-through sequence of 15 pairs of acrylic plastic domes, varying in colour and opacity. As Bourdon explained in The Plastic Art's Biggest Bubble, everybody gets a physical reaction out of body colour. Seen from the outside, people change colour, then disappear from view as they pass through different opaque units. So at the Architectural League, slipcover was in fact titled Environments 3 slipcover, and that was, as the title suggested, it was part of a series which included Environment 2 prisms, lenses, water and light. This was a collaboration with USCO. Also Environment 5, vibrations by light artists Jackie Casson and Rudy Stern. The series was an initiative of architect Ulrich Franzen, who had just become the director of the Architectural League and who in 1967 would be featured alongside Peter Blake in one of Levine's early video works, simply titled Architecture. And he screened this, I apologize for the image, he screened this as part of what he called a television series at the League called The Big Eye. So as suggested by critic Harold Rosenberg in October 67, and by this time, the term environment, encompassing both post-object art practices and work that engaged the spectator in a spatial unfolding, had itself become somewhat ubiquitous, if not simply a cliche. Referencing the series at the League, Rosenberg wryly noted that to label a project an environment qualifies it as significant and avant-garde. Yet to him, it came with subjection to control mechanisms that warranted interrogation. So if, as he argued, one could recognize the derivation of environmental art from the functionalist aesthetics of the Bauhaus, as well as its indebtedness to happenings and mixed media performances, there was an important historical distinction to be made. Stressing a shift from tropes of high modernism to paradigms of management and regulation, he explained, and I quote, "What separates the current art from the Bauhaus constructions is the rise of environments in a period when managed or programmed living space from dwellings to metropolitan cores is envisaged by architects, engineers, and community planners as dominating the environment, the sensations, and ultimately the decisions of the human masses. Space travel, too, has brought the necessity for completely controlled environments, both within the vehicles of transportation and at the point of arrival. To Buckminster Fuller, the living conditions of the astronaut are the first instance in human history of totally regulated space occupation, and to him the astronaut's cabin provides the ultimate model for a planned utilization of the world's resources. And he goes on, responding to phenomena of this order, environmental painters and sculptors carry their medium into the domain of architects and engineers. So at stake for Rosenberg, and certainly for many other critics, including Burnham, was, as he put it, the necessity of a renewed questioning of the viability of art and the position of the artist as creator of in the technological age. Indeed, we might recall Burnham had opened his systems aesthetic by musing on the rise of technocracy and of new paradigms of research. Already in California think tanks, he wrote, no doubt referring to the RAND Corporation. This would actually soon be a sort of key protagonist in Les Levine's conceptual works. And he goes on, and in the central planning committees of each Soviet, futurologists are concentrating on the role of technocracy, i.e. decision-making autonomy, how it handles the central storage of information, and the techniques used for smoothly implementing social change. In the automated state, power resides less in the control of traditional symbols of wealth than in information. And I'm concluding. So it is in such recognition then of the critical and conceptual interrogation of how the artist might operate within a contemporary society driven by computerized information and control mechanisms, precisely a systems environment, rather than in the more literal association of the work with architectural and urban spaces under the rubric of environment, that I think the key lessons of Levine's work lie, plastic work lie, at least for architecture. Art in the future will be like a think tank, Levine Riley proposed in 1969, suggesting later that year, the ecology of the United States is technology. In a text called Les Levine Business as Usual of 1970, Burnham returned to the provocation of the artist's use of plastic. Levine's clean machine, he goes on, is a most elegant summation of minimalist aesthetics, traditionally made palatable for some critics by the inclusion of various surface and spatial articulations relating to or defying older traditions, But Levine removed and transformed these illusions into sterile, vacuum-molded plastic projections, forcing us to deal with the question, can you accept this as an aesthetic experience, even if it is not prettied up with art historical illusions? Few of us could, end of quote. So the unpalatable nature of Levine's plastics works seemed to have arisen in part from his use of materials and what he considered to be the capacity of plastic to cleanse the visual environment of art historical references and illusions. As Bourdon also implied, to many it exhibited an uncomfortable or too visible proximity to corporate capitalism. Critics, he noted, disapprove of his popularity with corporations, which have showered him with thousands of dollars worth of materials. Moreover, as suggested in a work like Electric Shock, or actually in Contact I showed earlier, Levine spoke not only to the conventions of modernist artistic practice, its mediums and its modes of reception, which it certainly aimed to breach, as had minimalism, but also the subjection of the body to, and in turn the population, to emergent regimes of power, or the subject's inscription within a highly technologized spatial and temporal matrix through which they encountered, or we might even say, participated in micropolitical techniques of control. Exacerbated by his use of plastic, a material produced by multinational corporations and exhibiting an ever more capillary reach within mass culture and the everyday environment, the work that is alluded all too directly to the supremacy of American capitalism in the 1960s and its role in forging new regimes of governmentality through which this very technological, through this very technological milieu. So recall then, to finish, the opening of the wall text for the disposable walls and the clean machine. Caution, some plastics might be hazardous to your health. Thank you.
Next up, we have Hernan Diaz Alonso. We're going to make sure that we have our visuals working.
Try to reset it. I'm not going to do it upstairs. It's going to probably take a bit to reboot the system. Okay. Hang on. You're right. It says it's in there. It's detecting the two displays. Switching the I want to keep changing the input. Now we can try one last time to see if we can make it work in the PC. And it work it through. Now we'll be 14 minutes. It won't be a you good? I can talk for 5. I'll take that 14 minutes. No, you deserve it.
I know. Yes, I've asked her to get the tape. We're losing them. Should we go to another one? Looks good. Let's go to Chip.
No, but Chip has the same problem, it's Mac.
Yeah, but his Mac, Chip's Mac work? No, not yet.
I don't think it's a problem with Mac, I think it's a problem with the this connector here.
We can make it work. You have my PowerPoint.
Yes.
So we can use that.
Let's do
I
it.
think you should move ahead.
All right. What do you want to do? You want to try his here, or you want to move ahead?
Or, I think, yeah, we better start with this.
Okay. You want to do it on the PC? Do it on the PC.
Yeah, I mean, if we have to, right?
Yes, we have to. All right. We're actually going to go to Chip Lord. Macs are American products. They throw us for a loop here. I don't know if it has anything to do with our sensibilities, but Chip Lord, who is founder of Ant Farm.
Thank you. We can have the lights down. Thank you, Michael, for inviting me. We still have a little technical glitch here, so we're not going to see a series of movies, but I'm going to describe them to you. And I'm going to start with the Boston City Hall because when I was a student in 1963 at Tulane University studying architecture, this building was very influential. And there were other influences, obviously, but and it's not plastic. But I want to just set that image in your mind. By 1968, when I graduated, nobody wanted to go to work in an office and design branch banks because, after all, a branch bank had just been burned to the ground in Santa Barbara as a protest against the Vietnam War. And I shared that idea, and I went to San Francisco and met up with Doug Michaels there. And we started what we described as an underground architecture practice. And you have to understand there was a sense of an underground culture in San Francisco at that time in 1968 because you had underground newspapers and underground films. And so we described what we were doing as underground architecture, and a friend said, oh, like the plastic toy I had as a kid, the Ant Farm. Yes, that was instantly the name and the logo, and it also came with an official color, green. And as a metaphor, it was, on the one hand, it was a slice of life or a slice of reality, which we liked. Also, the ants worked collectively, and now we know that the hive has a greater intelligence than the individuals do. And then it was also a kit of parts, that you would put together, and it was high tech in a way as a toy. And of course, it was also plastic. And finally, the ants built underground these really interesting spaces. And of course, above ground was a very conventional architectural scene. So it was a perfect metaphor for what we were engaged in, but really we wanted to be rock stars, I have to admit. This is the album cover. In 2004, the Berkeley Art Museum mounted a retrospective of Ant Farm. And ironically, the building, the Berkeley Art Museum, is another classic of brutalist architecture designed by Mario Campi, I think, in the mid-60s. Ironic in the sense that then the kind of architectural experiments that we engaged in were symbolically the opposite of brutalism. They were experiments with the most lightweight structures, to wit a surplus cargo parachute is what we started with. And you know, it had this wonderful quality of being interactive, and you see Kelly Gloger here is controlling the shape of the architecture. And you could also ride in it. So it was interactive, and it was lightweight, and it was transportable, and it had it left a small footprint. It could only shelter you from the sun, really. It wasn't architecture in any other way, but symbolically, it was very important. And we added a form of collage, often simply superimposed imagery of two slides on top of each other. But it was a way of amplifying from these physical experiments, I think, towards an idea of architecture that would be expansive and in some ways imaginative and imaginary. So a series of these collages are demonstrated here in a light box that we made for the exhibition in 2008 here at Columbia, called Radical Hardware. Okay, the first movie. Imagine a 100 by 100 polyethylene sheet laid out that suddenly begins to inflate, and then we enter it, and people are walking around, stumbling around in this totally white space. That's the first movie. It may be actually timing out without showing it. I guess that could be what's happening. At any rate, the first inflatable that we did was 100 by 100 polyethylene. It was literally taped together, so it was very low tech architecturally, and it was taken to the Free Rolling Stones concert, Altamont, in 1969, and there it functioned as a kind of Bad Trips festival. That's the movie that you didn't see. The second movie, it's another brutalist building, the San Francisco Art Institute, and it's a red polyethylene tetrahedron inflating against this backdrop of the reinforced concrete spaces of the San Francisco Art Institute. So we've moved, slightly towards slightly more permanence with these inflatables that could be shown and demonstrated and then taken down and transported somewhere else and shown again. And so on Earth Day, at the invitation of the University of California at Berkeley, we staged this inflation, but also a kind of agit-propped event called the Clean Air Pod. And in 1970, and this was the first Earth Day, the sky over the San Francisco Bay Area was literally brown. So it wasn't a jump of the imagination to imagine a time when the air would be not breathable. And so what we did here was we, of course, made that into a fiction. And we had a megaphone, and we would announce, air emergency, everybody inside the clean air pod. People would go inside. And I think our lab coats gave us a certain authority, despite the fact that we may have also looked like a band of hippies. This is an altered news report from the Oakland Tribune. And, the point was made as a headline to them, I think. missing slide. This is a this is also a surprise. Let's see if the next one is there. Okay, this is the turbo dome. We went on to a slightly more professional, if you will, process by acquiring a radio frequency welder that enabled us to design and fabricate prototypes. And this one, in fact, the turbo dome, was a dome shape with 5 sleeping pods. And we did, in fact, live in this for about 6 weeks in a summer in Vermont in 1970. So we had advanced from use of polyethylene to vinyl, and vinyl of different gauges and durability. And what you see is the spare tire inflatable, which is a polyethylene object, really. You could not enter it, but it's here housed inside the 50 by 50 vinyl pillow, which was a commissioned work, actually, commissioned by a rock festival promoter who was going to Japan.
Don't worry, keep talking.
Oh, now we're changing the battery.
Ignore that lady behind the curtain. This was going to be surreptitious and secret. It turned out to be. And the battery's casing is plastic.
Okay. So what can go wrong will go wrong. Anyway, this was a commission. We designed it for a promoter who was going to take thousands of rock and roll fans to a festival in Japan, but the financing fell through. He never picked it up. We used it for other uses, including renting it to Stewart Brand and the Whole Earth catalog for the production at a remote location of the Whole Earth supplement in 1971. And you can also see a geodesic darkroom because they were actually making the publication and they needed a darkroom as well. It was a kind of package deal. Another time in 1970 at the Freestone Conference in Sebastopol in Northern California, which was a gathering of alternative architectural practitioners. It was convened by Sim Vanderen, and this inflatable was used as the main meeting room, or the big tent, let's say. And this is the third missing movie. And really, what I wanted to emphasize was the experiential, interactive quality of inflatables, because if you've never been in one, it does something to kids especially. And that's what you see in the movie, which we don't have. Kids running and throwing themselves against the walls. Or in the case of this structure, which was durable enough so that they could literally climb on top of it as it was being inflated. And it would continue to inflate around them, and it was like, it was an experience somewhat of between a plaything. Well, of course, that's become an offshoot of as a kind of industry for children's birthday parties with inflatables. But in 1970, it was a kind of revelation to see that type of experimentation, and to see that the structure itself was literally creating that in the users. And so after, I think, doing 20-some inflatables over the course of a year and a half, we collected what we had learned into the Inflato Cookbook. It was a self-published publication, very much in the spirit of the Whole Earth Catalog, do-it-yourself idea, access to tools. And we even made these vinyl binders with the loose pages, the idea being that you could spread the pages out on the floor with the materials, start cutting them and making inflatables instantly. The Inflato Cookbook sold for $3, And it's become a collector's item. And it's also online now. So I'm going to get to that in a minute, but the other things we did included traveling in a media van. There are plastic bubbles in this photo, which again was different from the hippie aesthetic, the sort of the back to the land. We were far from that. We were more interested in technology and an image of a technological image. And it was a media van because there was a Sony Portapack that we traveled with, and we could play it back from the van. And in addition, we took an inflatable. So it was kind of, we did a tour, the truck stop tour, and which was a demonstration project of a complete life support system for living on the road. In 1972, we actually got a commission to design a weekend house outside of Houston. And while it's made of ferro cement, I think there's obviously an influence of the work that was done in inflatables being translated then from bubbles to stone in a way. And another polymer, fiberglass, used to as a shellac on the woodwork. In 1973, we did a project, Freedom Land, which was a shopping mall for teenagers, and it would have a inflatable roof. And this was never built, and in fact, the model is a recreation that was made in 2008. We went on to do the Cadillac Ranch in 1974, and the Media Burn in 1975. And so we moved away, in some sense, from inflatable architecture. Although the Media Burn was involved in elaborate kind of exercise in graphic design as well as staging and video production. And just as a final epilogue, as I said, the Inflatable Cookbook is available online, and it has proved to be functional in the new millennium. In 2003, Roman Coppola, the film director, actually gave him an inflatable cookbook, and he subsequently built this 350-foot long inflatable in a hangar in Los Angeles to shoot the Toyota Prius introduction TV ad. And in 2008, there was a intervention art festival at UC Santa Cruz, and working with a group of students, my former partner, Curtis Schreier, worked with them, and they designed and built that inflatable. Another former student made this inflatable at the Harvard Graduate School of Design for a screening of the documentary. Filmmakers in the front row here, Space, Land, and Time, Underground Adventures with Ant Farm. And finally, this is Curtis attending the Climate Capsule exhibition and conference in Hamburg at the Museum for Kunst and Technics, I think, is how that translates. And he gave demonstrations there of making inflatables. So the point there is that there's a certain amount of use value that's still, amazingly enough, some almost 40 years later, the inflatable cookbook can be put to good use. And for a much more detailed and probably accurate description, I recommend Felicity's book, Living Archive 7. Thank you.
So we're still moving the program around. We're going to have Beatrice Colomina come up next and speak.
I don't know. Yeah, take it out of there. Here in the pocket. Yes, sir. Yes, in the pocket. Yes. Yes.
Thank you very much. Thank you, Michael, for organizing this incredible conference. You did it again, we can say. Yeah, every year you turn up with another amazing conference. Every time we are surprised of what thinking about a material can do for us. So plastic atmospheres, 1956, 2008, I have chosen these two examples. 1956 is the year of the House of the Future of Allison and Peter Smithson. So very quickly, 1956, outside it was a wooden rectangular box with almost blank walls, and there was a House of the Future somehow flashed on and off, projected into one of the large, the longer, walls. A small opening to one side, I don't know where, yes, here. To one side here, very discreet, right, acted as the entrance. And inside there was another blank box, more or less like this, which visitors will circle around, peeping it at ground level through these openings that were opening into the size of the wall only for that purpose. It doesn't mean that this house has these windows. This is just for the exhibition. Before ascending to this upper level, where a viewing platform circled the inner box, again allowing bird's eye view of the interior, before leaving the outer box through another discrete opening and descending on the grounds of the vast Olympia exhibition hall in London. The mysterious structure, which you can see here and also here in the bigger plan right there at the end of this Avenue of Tomorrow or something. This mysterious structure had been commissioned by the Daily Mail for their Jubilee Ideal Home exhibition and displayed there for exactly 25 days in March of 1956. Now, how are we to understand the House of the Future today? How can we discuss now a house of 1956 that try to imagine the future of 1981? That is, in other words, how can we look back in order to look forward? For years, the project was considered or ignored, more or less, as an anomaly in the practice of or in the careers of Allison and Peter Smithson, the project that didn't really fit with anything else they have done. It was indeed much discussed at that time. Banham was very enthusiastic about the house, called it like the first example of a pop architecture, etc. But then it was somehow forgotten from everybody's memory, almost disappeared until the last few years when it somehow regained some currency. Now, why is that? After half a century of ignoring the house seems almost impossible to ignore. Is it because somehow the sinuous curves of the house resonate with a renewed interest in bioformism and the growing sense that new moldable materials are a driving force in architecture, as we were talking yesterday, and as we saw yesterday with Greg Lynn, also we ended up with openings that are a little bit out of the Flintstones in the entrance of the House of the Future? Or is it perhaps a contemporary fascination with the 50s and with British pop in particular? Or is there perhaps something specific about the house, something about the house itself that somehow forces itself back upon us? To echo Richard Hamilton's famous collage from the same year, just what it is that makes this House of the Future so different, so appealing. If there is one word that describes this house that comes to mind when thinking about this house, is precisely plastic. The building is presumably made of plastic and is entirely filled with plastic objects. The chairs that were specifically designed by the Smithsonian for this purpose were all experiments with the new material. There is the pogo, the folding pogo chair that is in transparent perpex and steel. There is the egg chair that was, because all the photographs are, most of the photographs are black and white, I have to tell you the colors. One of them was in honey color and the other one citrus yellow. There is the petal, one of which was pimiento red and the other honey color, and there is the white saddle, which all of those that I just mentioned were all made in, molded in reinforced polyester resins and seem to, in a way, share the character of the double curve modeling of the house itself. Here are the molds for these chairs. In any way, we continue. The kitchen sink, the sunken bath, the cubicle for the shower were all made of polyester fiberglass molding in pimiento red. The mattress and the headrest for the bed were made of latex and covered with a nylon sheets. The curtains were also made of this somehow orange curtains that you have also seen all the time. They are also plastic. They are fiberglass curtains. In the living room, there is this cushion there that is somehow also made of a nylon, blue nylon fur. A never realized suspended cloud was envisioned in pale blue nylon stretched over a light metal structure. The working surfaces in the kitchen and the cupboards were all in peach pine waterite, and even the food had been packed in these airtight plastic containers. And House Beautiful actually describe the house as a Wellesian fantasy in plastic, with herrings wrapped in polyethylene and eggs without shell individually packed in little plastic sachets, the whites separated from the yolks. Jack, right? But I mean, here is actually the son of the Smithson, Simon Smithson, looking very perplexed at the food in the fridge. So the house of the future was indeed a showcase of plastic, and the showcase itself took its logic from plastic. The exhibition catalog describes the structure of the house as a kind of a skin structure where floor, walls, and ceiling are a continuous surface. So we can say then is that what the house of the future is, a plastic house with curves, a kind of a skin structure, the smooth, rounded look of mid to late 50s architecture and design of all these projects we have seen since this morning, of the Monsanto house of the future, in Disneyland of 1956 too, of Lionel, again the house of Monsanto house, of Lionel sign Maison Plastique, and also his cabin hoteliers, also of 1956, believe in 1956. I mean, if 1968 is the year that, as the Ecologies says, that the art world discovered plastic, one can say that 56 is the year that architecture discovered plastic, so we can say that for once we were first. It's also the year of, well, not the year, this came a little bit earlier, but you can also think about the Eames fiberglass chairs. This one is also very close to the logic of the house of the future. The Saarinen chair, actually, the tulip chair is precisely from that year, from 1956. You can also think of the wall of Tupperware, again, the petal and all these Tupperware objects here on a highway. In other words, the house then, like a plastic consumer product that is supposed to be mass-produced and assembled like the molded panels of a car. But this is the thing, that house of the plastic learned from plastic. It had the aura of plastic, which is, of course, the dream material of the time. Popular magazines have been heralding the arrival of the new material for some years. For example, there is this 1952 article in Life magazine called Houseful of Plastic, which somehow catalogs the endless plastics contents of any American ranch-style house. A house, any house, according to Life magazine, could be turned into a dream house by simply filling in all this dream material. 4 years later, experimental architects were turning the container, the house itself, into plastic. But the house of plastic then was also understood by the press as a kind of plastic polemic. Article after article kind of points out to every plastic feature of the house, plastic everywhere. If you can read from there, plastic niches, plastic walls, translucent plastic walls, chairs of plastic, food packaging, and even, of course, the clothes that are worn by the occupants living in the acting. It's like a kind of an opera, this house of the future. They enact the life of the future. Actually, the clothes were designed by this famous fashion designer, Terry Tinglin. Terry Tinglin was a designer of sportswear. He used to do the tennis outfit for Wimbledon. Right? But if you look closely, you see plastic this, plastic that. As a journalist described it, for him, a Superman space outfit of nylon sweats and ties with plastic foam rubber-fitted soles, and for her, the pixie, the pixie look, a sort of nylon skirt with a scallop edge, and ties with high heel, again, fitted plastic foam soles. But in fact, and this I suppose is the punchline here, and here you see more images of the actors in the house. but I know. But in fact, and again, more clippings. Always the plastic home even has a garden inside, right? But in fact, what is amazing is that the plastic house was actually not made of plastic at all. It was a simulation. It was a full-scale mock-up in plywood, plaster, and emulsion paint that is very traditional materials collaborating to produce the effect of a continuous molded plastic surface. As Peter Smithson put it, it wasn't real. It was made of plywood. It was like a design for a mask, like theater, end of the quote. So it was make-believe then. Even the transparent plastic wall to the garden of the house was fake. I mean, this that appears to be the plastic enclosure is really thin chromium wires, tension between the floor and ceiling, creating for the viewer the illusion that the curved transparent wall molded in reinforced plastic that was described in the brochure of the house was when in fact the opening was left unglazed, as you can see here in this picture, where a piece of clothing is just left hanging right there over the edge. In case you missed it. Anyway, the Smithsonian saw the tradition of these temporary theatrical structures as a centuries-old tradition going back at least to the Renaissance, when architects were commissioned, for example, to do the architectural settings for and the decorations for the wedding of a prince, or for the birthday of a ducal daughter, or for the entry of a pope in a city-state. These events, Peter Smithson said, were used as opportunities by architects for the realization of the new style, the new sort of space made real perhaps for a single day, the transient, enjoyably consumed, creating the test for the permanent, end of the quote. So, like in the Renaissance then, the house of the future was stage architecture, a simmering mask, which doesn't make the proposal less provocative, but perhaps more. Like all exhibitions, they live a life of a few weeks, but then they go on and on forever. Like the Barcelona pavilion, before it was reconstructed, the temporary turns out to be permanent. Okay, so 2008, Sana in Barcelona. She says, or they say, we decided, let me focus on you. We decided to use acrylic to make a transparent curtain. We imagine an installation design that leaves the 16 space of the Barcelona pavilion undisturbed. The acrylic curtain stands freely on the floor and is shaped in a calm spiral. The curtain softly encompasses the spaces within the pavilion and creates a new atmosphere. The view through the acrylic wall the view through the acrylic will be something different from the original, with soft reflections slightly distorting the pavilion. Sana in the Barcelona pavilion could be indeed considered the ultimate encounter, since Sana is widely considered the inheritor of Miesian transparency, a challenge, as Sejima herself said when giving the commission, or we can say a return to the scene of the crime. The installation carefully marks a part of the pavilion with an acrylic curtain, acting as a kind of crime scene tape, leaving, as Sana put it, the space of the Barcelona pavilion undisturbed. But what crime has been committed here? What has been cordoned off? Is it the free-standing golden onyx wall at the center of the pavilion, now wrapped up by this new transparent curtain in a calm spiral? Or is it the two Barcelona chairs where the king of Spain, Alfonso XIII of Bourbon, and his wife, Queen Victoria Eugenia, were supposed to sit during the opening ceremonies on May 1929? Or is it the space outside the spiral that has been marked off, preserved, kept undisturbed? In any case, the cordon is loose. The spiral is open. We can walk in, but not so easily. First, we have to find the entrance, slide around the outside of the curtain, and only when we are on the other side of the space of the pavilion, now divided by this curtain, can we now suddenly fall back into the spiral by making a 180-degree turn, which in turn, I think, echoes the 180 degrees turns already required to enter the Barcelona pavilion. I'm talking about this move that Mies makes you make, right? And here again, you go this way, pop, or the other way, of course, but I don't think anybody will go that way, but still you have to go all the way around, right? Just as Mies somehow narrowed the entrance now, subtly constraining the visitor with a folded path, Sana squeezes and spins and squeezes the visitor between the narrow planes of acrylic that curve around until suddenly one is inside, facing the two Barcelona chairs, or rather they are facing us, as if the king and queen were still there, sitting down, presiding over everything. There is a new chair. Did you notice that? There is a new chair besides us. It is one of these Sana plywood chairs with the two asymmetrical bunny ears, whimsical, playful, uncomfortable, funny. A kind of angled, inexpensive school cafeteria chair facing the white, ceremonial, orthogonal, plush, leather and chrome chairs of Mies in some kind of playful challenge. And here is a possible reading of this chair of Sana. We may have been inspired by the Playboy chair of 1970. The new chair, of course, represents Sana, just as much as the old one represents Mies. The new chair belongs to the acrylic curve, while the old chairs belong to the marble, right? But what do they mean when they say the pavilion is undisturbed? Something has changed. In fact, everything seems to have changed. The plastic spiral makes a new pavilion out of the old one. A pavilion inside a pavilion is transforming the other to produce a whole new architecture. The most famous pavilion of the 20th century becomes something else with all these additional layers of reflections. All these classic images embedded somehow in the brain of every architect now have changed, have additional levels of reflection. Now, Sana, what they do is return the curtain to the pavilion, or perhaps it's the pavilion to the curtain. The acrylic free-standing curtain recalls the silk and velvet cafe, a brilliant collaboration of Lily Reich with Mies van der Rohe in Berlin 2 years before the Barcelona, where draperies in black, orange, and red velvet and black and yellow silk hung from metal rods to form the space. The cafe is a kind of prototype of the pavilion, if you think about it, in its radical approach to defining the space by suspending sensual surface. In the pavilion, the vein, here is Lily Reich, in the pavilion is precisely the vein, the richly veined marble surfaces that take over the role of the curtain. The hard surfaces absorbing softness. In fact, Mies pretends that these walls are curtains when they say they don't hold any weight, right? Denying that they have any structural role, even if we know in the end that they did, right? Sana projects then returns, reminds us that the Barcelona pavilion comes from curtains, from a soft material. In the beginning, there was the curtain. It is, of course, a Schemperian idea of architecture. But the space that Sana has protected with the curtains of the pavilion is precisely the center, the throne room, the space where the king and the queen of Spain would have occupied. I mean, they were supposed to sit down and sign the book there, but apparently they never did. I mean, it's funny, on the other hand, I don't know that I saw them that they did. And they're so little that the two of them fit in just a little stool of Mies, right? When Mies, of course, if you see him sitting in one of the chairs, you understand the size of the chair. All right. So, in all photographs, these are all photographs from the press. You've never seen them before. All the space is marked with this black carpet on the floor, which nobody seems to dare to step in. I like to think that this woman on the edge also is maybe Lily Wright, who is, of course, working with Mies in the pavilion and the other installations in Barcelona. Zona curtain is precisely the invisible clock which further protects this space. A kind of, if you think about a royal transparent clock, like in this painting of Goya, of Fernando VII of Spain in 1814. Of course, he is from the same family of the king. The garment is billowing, is moving. It billows outside, allowing us to enter in its folds. A space is defined as a kind of invisible movement, neither limited nor unlimited, a paradox that the spiral has always communicated. Sana's diaphanous curtain preserves the pavilion in allowing it to breathe. It is a kind, if you want, of life support in a moment in which the subtlety of Mies might be so easily forgotten, precisely because the building is so insistently celebrated. The single curtain slows us down, allows us to enter into the pavilion again, as if it was the day of its opening, right? And here you have some images again from the press with the King of Spain and Mies, and again the King of Spain. It is what allows Sana to take us back to this moment is precisely that the curtain is precisely not transparent. What is added is not a clear window, but a delicate veil. Sana's acrylic, like her glass, is never neutral. Sana's vision, as with her glass, is whether it's glass or plastic, is always the same, is never crystal clear. In fact, their architecture appears to be more interested in a blurring of the view, a softening of the focus, than sustaining the transparency of the early avant-garde architecture. So Isejima is the inheritor of Miesian transparency, the latest in a long line of experiment. She, I think, is the ultimate Miesian, deepening the logic of transparency into a whole new kind of mirage effect. The temporary acrylic curtain in Barcelona intensifies the Miesian effect. A plastic lens is placed inside a glass lens to intensify and therefore prolong the Miesian effect, the mask of modern architecture. The ghost here is an ambiguously modern architecture, preserved rather than transformed by a subtle deflection. If the theatrical performance of the Smithsons in 1956 looked forward to the plastic future, the theater of Sana uses plastic itself to look tenderly backwards. It is the disturbance of the plastics that allows things to return to us undisturbed. Thank you very much.
So I'm going to go as quick as I can because I think everybody is reaching the point of freezing to death. I think 8 hours is what the human body can take in this cold. So I'll do my best to get you out of here as soon as I can. If technology allows it, which is always the case that everything goes wrong. So already it was difficult for me to talk in the context of this conference. So on top of that, with all the technological problems, it gets even more difficult. Thank you, Michael Bell, to putting this together. When Michael invited me to be part of this, I said yes, and then I started to think, okay, I really don't think I have much to contribute to the context of this problem for the simple reason that for those who know me, I'm very opinionated about pretty much everything, except when it comes to materials. I never have a strong opinion about any kind of material whatsoever, probably because we don't get to build much. So that never been like a super at the front concern. I'll see how long I can go without the images. Are we getting somewhere? No. Okay. PowerPoint is crashing. Okay. Now they're taking the microphone away. So, okay, let's see if I can tell you a couple of thoughts where I decide that I can go with this conversation. And the thing was that I started to think about all the words, all the things that had to do with plastic, that I have an interest as a designer. And the first one that came to mind was plastic surgery, because I live in Los Angeles, seems like a good relationship, but also they have to do with the notion of transformation and perversion and mutation, which is something I find incredibly interesting, and also because it had to do with the replacement of certain, let's say, artificial artifacts that help to do other things. I mean, this is impossible. Looking at what is going on. Yeah. So, Michael is gone, Ben is gone. I really don't know what to do, man. Okay.
Your work is so well known.
No.
That we
so
could.
I cannot do that, Michael.
We
can go to the panel
discussion.
Sure.
Yes,
I
it's
mean,
one of the more well-known. And if the images were not recuperated in the last hour, I don't believe they're going to be recuperated.
No, they're just copying them. Anyway,
Still?
whatever. Yeah. They're there.
Does John Ramallo have a prognosis? Can we get an answer that is yes, no, or a period of time? Does that mean 2 minutes? 2 minutes. I would suggest if you want to speak for 2 minutes, they say you will have images in 2 minutes.
Okay, I can talk for 2 minutes. Huh? Yeah, but it doesn't work from here. So anyway, 60 seconds seems like, okay, so 55 seconds, okay. So plastic surgery was one of them. The other one that came to mind was the notion of, what it have to do with the way in Spanish and Argentinian way to understand art. In Argentina, art, with capital A, is called artes plásticas, plastic art, which is something that we inherit from the Beaux Arts. And I thought that was an interesting idea, too, in terms of how you can manipulate and articulate those kind of conditions. And the way I started to think that I can relate those parts was in relation to film and cinematic effects, which is something that interests me a lot, particularly since we operate and work with animation software and those kind of models of production. And in a weird way, the film industry has gone backwards in that sense. If you look at all the visual effects, pre-computer were made most of them out of plastic and composite and miniatures and all that. And then computer come on board and replace all that into a whole different territory. But then for architects, or what I do, what I like about plastics is it gives me something that is one of the words I hate the most, which is hope. So every time that we do a project, I always hope that plastic and composite industry is going to carry on us there. So for that, I'm grateful to plastics. So the other piece of the component, and now what is the problem? We copy the images, but they're not opening? It's opening. Okay. Okay, here we go, finally. Okay, there we go. I don't think the movie is going to play, but I just wanted to show this because this is how I felt when Michael invited me to do the thing. I feel like Dustin Hoffman, and he's take me away and say, I have one word for you, plastic. There is a great future in there. Here we are, 45-something years later, discussing that possible future about plastics. Don't worry about that movie. Really, that doesn't matter. Everybody knows it. Actually, I was surprised that nobody used it until now. So basically, these are 6 or 7 categories that you usually have to do in relation with my own work in any lecture I will give. And I add certain things here to see if I can make a stick to the content of what we're discussing here. So for me, all is about cinematics, effect, desire, form, form. Grotesque, horrific, I would argue plasticity. I mean, the way that you will deform your face to scare a kid or something like that. It has to do with that. But also, as I was saying, and we were talking with Fabio Marcaccio outside about this, and he was saying that animation and digital production, he will see it inside the plasticity part of the problem. Image production of form, fake. Coming from Argentina, plastic for me is automatically fake. I was educated in that notion, everything had to do with plastic was a fake thing. It was a fake material. It was about all those things. And I would say some of the things I saw today, it have to do a little bit with that. By the way, I was absolutely amazed that Levin was the vice president of sculpture. Who was the president? So editing and composition as a mechanism to reorganize images, but also composite and all that, virtuosity and lust and arousal. So if you think about anything that have to do with sex, plastic come to mind when you're talking to artificial help. But it's a different whole territory, and I think some of the speakers will talk about that tomorrow. So fakeness is the closest thing I can come with something I can use for this conversation. So I don't even know if that is really a word, but this is where I was talking about plastic surgery and plasticity and deformation, but how that can be manipulated into something much more sophisticated that can appeal to other things. This is Alexander McQueen collection, I think, for 2008, when he took the Botox trend in mouth, and he developed a whole different aesthetic into the thing. But this is what I was mentioning before about, this is how movie were done. The guy who did those effects for Star Wars basically went and bought a bunch of plastic toys and melt them and reconfigured them into the spaceships. That's why they look in the way that they look. But then that got replaced in more recent time with digital CGI. This case in the left is the real Keanu Reeves and the right the fake one. Not that when it comes to acting makes much of a difference in his case. But to me, this has to do with a kind of this idea of plasticity and the idea of plasticity as a design sensibility, as a design strategy. So many of the things have to do with experiments, and as I mean, yesterday, Greg Lynn's keynote speaking, it was extraordinary in framing that part of the problem. My brain, unfortunately, doesn't have that level of brilliance to articulate the thing, and as I said, I have a much more corrupt way to think of problems than Greg does. But nevertheless, I would call it a series of experiments that have to deal with new things. And again, even in the manufacturing and the prototyping level, the notion of plastics and composites and all that plays an incredible role in terms of give us hope in terms of what we can do. And in this case, they're all models and all that. The second episode, I would say a lot of the same, was where the idea that we were trying to work what I call cellular system or cellular growth. It's a fancy word, but basically it was a way to produce incremental variation of a singular entity, and how that have that kind of animated quality, this kind of a plasticity manipulation of it, but also it will have in this particular project a direct implication in terms of the materiality. The notion of the horrific, of the grotesque, and the permanent state of mutation, which is something that obsessed me, it became in this particular case a material effect. This was the original prototype when we were planning to do the thing in fiberglass. Then the fiberglass only became to the pieces on the ground. But the other thing was interesting is when you produce this in a vacuum, in a perfect laboratory of manufacturing environment, you get the perfect shining composite, in this case benches that they look like little elephants. And we always like to show this kind of picture with these people that look very scientific. And then you bring it to New York, to the humidity of New York, and you're accelerating the process, and you're working with very tight budget. And then the perfection of the plastic allow the fakeness to start to appear and the distortion. So all these benches, when we brought them to New York, after the plastic configuration was not properly cooked, it started to develop blisters and start to break the painting. And when that happened, the guy who manufactured literally was crying. It was the same day that the Nicholas Urosov from the New York Times came to see the piece. And he said, but that goes perfectly in what you're interested in, the grotesque and the horrific. And I said, but yeah, but of course. I mean, we did that on purpose. But what you learn is these things have a certain properties and certain conditions, certain transformation, and that became to me like a really interesting material to start to work on that. So when we got another commission for a show in a museum, we start to think as a possibility to do that on purpose. So we accelerate the process of assembly. This is a regular, original was milled, then sanded and put it by hand, and then we painted on top. And but we accelerate the process, and you can see all the blisters start to merge. So over a period of time, the thing will be in constant flux. So as I said, I don't have a commitment or any intellectual reason when we work with materials. I'm much more interested in the form possibilities, in the arousal quality, in the material effects, in the sense of whatever material will get the job done, that's the one that we go with. And usually plastics and composites are the most flexible to do the kind of stuff that we want to do, especially when they come to the smaller scale. So I'm skipping some of the animations so we can make it on time. But that, to me, this project became like a really important project in the sense of this one go to the stream with this notion of the fake materiality. So this was a show that we did in the Mack Museum in Vienna 3 years ago. And the idea was to produce this series of 18 objects that they will be placed in a gallery. And originally we were supposed to do in casting in metal, which was cheaper, but then the shipment was way more expensive. So we partnered with the Toyota Robotic Lab in Kentucky, and they produced this with this plastic 3D printing, but very high quality resolution that can be done in some particular way. I'm so involved with this process that I didn't even go there to see how it goes. I mean, I have somebody who I work and collaborate on regular times, and they take care of that. And then we took them to General Motors in Detroit, and they chromed the plastic. So the thing really looked like they're made out of metal, but they're made out of plastic and incredibly light. So we can send all of them in a cardboard box by FedEx for $500, which allows us to have $15,000 more to produce it. And so we cut that thing in the budget. Not that that's really important, but people throw numbers and money in this kind of conversation, so I thought I should do the same. And the trick was that the pieces were all the same. The only thing we produced variation through the legs. So that would give us the series of effects that we were trying to do, which was to capture this sense of movement and animation, cinematic quality in architectural space. Even though the objects operate at the art scale, the effect is an architectural effect. So the idea through the reflections and what we start to capture. And the interesting thing is the chrome process with the plastic process, they have a moment of collapse. So they were perfectly chrome for 6 months. In the month 7, they start to deteriorate and become transparent again, which I was super fascinated by that. But the Francesca Monhasburn and the Thyssen Bornavisa collection, who bought half of the show, they were not so happy about it. They didn't like the idea transformation, so but General Motors were very touched in their price, so they re-chromed them. But I like that. So we are working in a new show that the idea is that we're going to use that and we're going to see the plastic eating the chrome over time. The plastics are very unfriendly material that I find out. This is another one of those that became as a byproduct of a different project. So the idea was to work with one of the iconic IMS chairs, and this was one of the first experiments that we did with scripting, by using the scripting as a virus that will attack an existing condition. So we start with the IMS chair, and through the scripting, it deformed into something else. This was commissioned by the Art Institute in Chicago. And the way that the manufacture-wise is not really innovative. It was a regular milling form and then coating and polyurethane and finishes in car painting. But again, it has to do with this idea of liquidity and almost melting plastics and a mutation, almost plastic sergeant quality. So you will take something like this and start to deform and manipulate through a series of design decisions that it will take you to a kind of, hopefully, a deformed territory. The last one, which is the misfits, what I would say is the one I'm more interested in right now. It has to do less and less with that problem. And it was generated from that project that we did for the John Lerner exhibition, The Hammer. And then it took form in the first version that we did for another Silverware collection of Alessia. As I mentioned already, I'm not as clever as Greg in thinking one logic to develop it. I mean, we designed more old school, and then we did the prototypes in plastic. but the molds to do it in metal were too expensive, so that idea didn't fly. But we used that technology of the chrome plastic for an installation in Selfridges in London. And Rituals is where we're going now, and it has to do with this desire of, this is this idea to start to incorporate certain raw quality into this kind of high-end way to produce and design. And the idea came from, for the next version of the Alessi Silverware collection from the Ringers of Cronenberg, all those pieces, they are made out of paper. They are not made out of metal, so they are completely fake, but they produce this very scary feeling because it's associated to giving birth and all the other conditions that come with one novel called Rituals, but also the context of materials and the context of what they implied is very scary. So the new version that we did for Alessi is called Instruments of Manner, and it's this one which, well, it has a long animation that I'm not going to show, but they have the whole thing from bottle openers to silverware. They're very, I mean, you have to use it in a particular way to don't get harmed. But that's something that interests me because I think it changed the way the protocols that you will eat and you relate and so on. But I'm trying to convince them to make it out of plastics and chrome then and do it in high-end hotels and airlines. So we find a place in China that will manufacture all the plastic and then we can chrome them. But they keep insisting to do it in metal, so my sense is this is going to die like the other version. But the show at the MAC, it triggered this thing which I'm very, very interested with. Again, this plastic posing as metal. So a series of small installations that we work lately. One is for the MAC with half of these are real flowers, half of them are plastic flowers. So the real flowers start to fade out and smell very bad. And the last thing I will show you to wrap it up are the two versions of the Thyssen-Bornemisza Museum and Pavilion that we're doing in Patagonia in Argentina. That was the original version, which it was 70% the pavilion, 30% garden. And the idea was to allow this. That's not real nature. That need to be plastic flowers after Frank Gehry's advice that real flower will die in that metal. But the idea is to produce that nation of fakeness that grow and interact with the building. These are some pictures of the models. So the last thing, which is the one, last 20 seconds, maybe I'm getting older and going back to my roots in Argentina and cooking the whole cow and all that, and gaucho thing. But the idea is at the end of the day, we're going to have to use this with kind of a contemporary materials and contemporary way to produce that. So this chair and that bench, only 20% will be real metal. The rest can be done in plastic and molded in plastic and posing as metal. So only, and that will be synthetic cow skin. And this is the last version of the Thyssen-Bornemisza Contemporary Pavilion. And this is the only animation I'll show you, so I'll shut up. My time is up. According to my clock, it's not yet up, but I'll take the word of our moderator for. So hopefully it will play, and if not, so be it. Okay, so you will see here, I mean, thinking in rubber chickens, and so I thought maybe rubber cows. But in this case, the pavilion got reduced to 30% and 17% will be garden. So, again, the plasticity of this, and the animation about it, is the idea that you can manipulate and stretch anything as a way to different aesthetics. And then, to be absolutely honest, the material aspect of that notion of plasticity is more like an influential of the design quality. There has been more in an influence in the way that we produce. But one way or another, you always find a way to start to relate with that. So all the pieces that we're doing outside, which are probably the only ones that will get built, that they look like this, eventually they're going to have to be some kind of fake material posing like that. So that quality, which I think it was so diminished in early 60s and 70s about plastic, is what I found the most interesting and fundamental. This idea that things are not what they seem to be, and I don't know, that maybe has to do with, it's almost criminal again modernism, but again, looking at meat again, I always have the sense that meat was a little bit of that with material. I always feel like fake and used in a particular fake way. Maybe it's not true, maybe it's criminal to say something like that. But there is, for me, there's an interesting way right now. Don't look so much going into the future, but the idea is to mix it with very primitive, the very high-end way to produce design, and the very high-end manufacturing. And in that negotiation, kind of a new territory for design possibilities can emerge. That's it.
We can take, I believe, about 8 minutes of questions, so if the panel wouldn't mind, I think even if there's one question. And I think we've created a new genre, which is create an emergency and then have a brilliant talk. Thank you, Hernan. Yes. Patient colleagues.
Does somebody have a brilliant question, considering we have time for 1 or 2 questions? Or not so brilliant question? What's that? You want me to do we have any questions? We must have some questions. Yeah.
The formation of plastic not necessarily driven by the material quality or what it enables, but rather sort of reversely enabled by sort of utopian ideas of the future. That like the formation or the form or the morphology of plastic was, and how that might have been influenced sort of the other way around, that a sort of history of science fiction looking forward into the future might have been the actual sort of generator of these kinds of forms rather than the sort of plasticity or the material nature of plastic enabling that kind of form. Like I'm wondering if, I was thinking about the house of tomorrow or the house of the future, and the way in which, yeah, like the form of the plastic would be generated by the narrative of the future as seen by a present, rather than a sort of, you know, rather than a simple approach of what can we do with this new material.
Yeah, I think you're right. I mean, it's not an accident that all the experiments that we have talked about, all the plastic house of the future, the vinyl, they were all for fairs, for situations in which you were thinking about the house of tomorrow. Even the Formica house is presented in the fair of New York. So, and of course, in this context, is also in the context in which you're right, that architecture borrows from science fiction. It always does, actually. Architecture is always about the future, right? So in that sense, it makes sense, a lot of sense, the relationship between architecture and science fiction, and we don't quite acknowledge it sufficiently, I suppose. Right?
One great thing about science fiction, you realize it's every 30 years into the future. Like, The Man was the mind of 1980 in the 50s. Then Blade Runner is 1982, the movie, and the future is in 2012. Right. It seems like beyond 30 years it's not appropriate. Right. I mean, I don't know why, but it seems like a natural cycle of science fiction.
It's interesting that you say that, because when they were commissioned to do this house of the future, the Daily Mail wanted it more into the future, and the Smithsonian said, no, the maximum that we can predict, that an architect can predict the future is 25 years, right? Accurately predict the future, which is fascinating. How did they come up with this idea? That's why it's the house of life. In film is 30, and they decided, and they say it was backed from scientific evidence, that any projection of the future. Actually, another thing that is interesting too is that it's the future, but it's also the present, because one of the factors that I didn't talk about here, because there was no time, is the question of the space program. I mean, the Sputnik is about to put into orbit in 1957 what used to be, before it was called NASA, it was called something else, I don't remember. But anyway, they were already into the space program, and there were a lot of, and the fantasy of the life that the inhabitants of the house of the future, their work will be, for example, be an astronaut. For example, in describing the clothing, Teddy Tinglin says, you know, of course, an astronaut suit will be very much the same for a man than for a woman. Therefore, I'm pretty sure that a woman will want in her well-tempered environment of the house to return to the femininity of this kind of clothes, and that's why he designs these very short skirts and all of that. But the idea that they will be an long times of leisure, right? Because precisely they will be working, for example, as astronauts, right? And then therefore, and that's why they are always at home and doing, you know, and these two couples at home, and what are they doing there, right? I mean, all this time, right?
Doesn't entirely respond to your question, but watching Hernan's last video, I couldn't stop thinking about a sort of strange future past scenario in which, of course, the first American plastics, were produced out of a competition to find a substitute for billiard balls, for ivory, to try and save elephants, save elephant herds. So here in your project, with these animals being strung up, this is sort of fantastic, sort of uncanny resonance, I think, with the with this origin story, a sort of key origin story. And it doesn't really speak to your question, but I think the sort of future past thing is also, at stake, and dreaming of the future and any type of sort of futurological projection. They're often, you find, haunted by strange, disturbing prehistories. So.
Any questions? So I'm sort of curious about thinking about Hernan's talk in relationship to some of the themes that emerged before. It seems that on one hand we have plastic is tied to the epitome of fakeness, right? Mm-hmm. Which sort of gets architecturally understood as being related to the Baroque and all of its kind of manipulations of materials, bricks acting like liquid and whatnot. On the other hand, we have, for instance, Felicity's talk, there's a certain claim that plastic reveals a kind of deep real, a phenomenological real, the real that's not typically seen, that's that needs a kind of that needs the kind of bracketing and distance that plastic can provide in order to reveal what's truly going on bodily. So what does this tell us about plastic? If it does all of these things, then what does it do? I guess my question is, how do we reconcile these various notions of plastic?
With the exception of Smithson, everybody was distorting things, and I think in Beatrice's talk about Sejima, it's real clear that plastic is so different than glass because it's distorted, or it works like a different kind of a lens in a certain way. The reflections and all that of the acrylic are so different. It seemed like the one thing common was curvature and distortion and all of this kind of bending that doesn't happen with the other materials. Which doesn't make it fake. It actually is maybe an intrinsic property of plastics, perhaps. I don't know.
What I was talking about fake is more like the perception of fake. There's nothing fake about plastic. Yeah, but it's something, ultimate truth. But I don't know, when you go to cars, I'm not going to mention what car because in some of the ecological things that we saw today would be embarrassing, but a very expensive German car with the name P. They're very valuable until 1999, because that was the last, what is called the last P German car, that it was completely out of metal and composites aluminum. 2000 was the first one when Toyota took over management and they started to incorporate plastic composite. So the value of that as a collector piece for almost until 2 or 3 years ago, it was that car the price will go down very fast. But in the last auction, 2 or 3 months ago, the first version with the first plastic composite of that German car, already the prices start to skyrocket because everybody starts to accept that it's part of the sign of time. So there is also, for me, you have to do always materials always belong to a particular period of time and so on. And it's kind of funny, again, that 40 years after Mike Nichols and that speech of a drunk man in LA, talking about plastic in the future, it took us a while and we keep discussing like it's something like it's innovative and all that, and it is to one level, but when you look back, it has been around for a long, long time. What I think it changed is the negotiation with the body, with culture and design and manufacturing and all the other things. And I think that belongs to a different kind of problem that I don't know if any conference can answer. We have to do the way that you perceive things. Like, if you look, some of the most recent jewelry of Alexander McQueen are made out of plastic, and they cost like $3,000 or $4,000. So, and it's done in a mold. So you're not really paying for the material, you're paying for the thought that a designer put into that, and plastic is very Asian and contemporary and hip and all that. So all these other values about what I was talking about. So for me, fake is not necessarily about work. It was more about the idea of that you can use the thing to be more than what they are.
No, I agree with that. And also about the distortions, I wanted to respond to what just Greg said, because I'm not so sure. In the case of Sejima, for example, I mean, I think of Sana, they have been consistently misread. I mean, and that's what actually led me to start thinking about their work. I mean, the idea of the transparency of their work and the inheritors of Mises transparency, and then you look at their work and you say, but I mean, wait a minute. I mean, precisely they use very transparent glass to create this kind of blurring of the view, these distorting effects that you see very clearly in their renderings, but also in photographs that are not. I mean, it was interesting when she came here for the glass conference. I don't know whether you remember that fantastic moment when she talked about how photographers in front of the glass pavilion in Toledo will spend there the entire day until there will be some moment in which the angle of the light or whatever will produce the effect of transparent pavilion, and then photograph the when in fact, if you just go there, I mean, it's closer to what she has rendered, this kind of milky, blurry, snowy, kind of foggy view, which is again a more tactile sense of vision, which is clearly her aim, both working in plastic and in glass. I don't think it's so different.
Maybe at risk of sounding somewhat too art historical here, that one footnote I would add was that it was precisely the phenomenological dimension and the worldly dimension that was, of course, so disturbing about minimalist practice, including Levine's work, to people like Michael Fried, who I cited very briefly in The Art and Object, where the art, of course, was supposed to be a sort of transcendental idealist object. Painting and sculpture, was precisely not supposed to open into this type of realm. And so, I mean, for me, it's less a case of reconciling, than of putting into a type of discursive framework, how this departed from modernism. And so, that's really what I was trying to do.
I think, number one, for the sake of time, there's a second keynote lecture by Michael Graves, and that will come up on the screen. But I wanted to, this conversation, I wish it could go on for another 40 minutes. I want to say this is kind of a dream team that we've dreamed of putting together, Hernan with Chip, with Beatrice and Felicity and Brian. So I hope what will happen here is that this conversation can actually continue tomorrow in another format. There's half the audience is already in the other auditorium, along with our dean, who I'm sure is waiting for us to transfer over. So, is the dean here? There you are. There we go.
There's our dean.
Thank you. I saw Mark.